Hello students, I am Aksharvat Gautam and welcome to The Academy UPSC Civil Service Exams Prelims 2026 Current Affair course. Now this course is basically a combined current affairs for science and environment. It's a combined current affair module for the subject of science and technology and ecology environment. Now students, all of you are probably aware, because if you have reached to this point, I am hoping that all of you are already aware that these two subjects alone, they have a weightage of nearly 25% to 30% of the question paper. You can expect at least 25 questions from this particular module, and I'm also targeting as a faculty, I'm targeting that this module should be able to help students in achieving at least 25% of the questions. They should be able to do it, right? Now, in this particular module, what is the time frame that I'm going to cover? So we are going to cover a time frame from 1st of January 2025 till 31st of March 2026. The lecture plan is already shared, right? And you guys can also, just to share further information about the lecture plan, I'm going to share some details here itself. So when you look at this entire module, I'm going to cover the current affairs from 1st January 2025 to 31st March 2026. Now, what all things a student is likely to get when they join this course? What are the various, study material and other inputs that a student is likely to get when they join this course? So, like I said, this course is starting today, 10th of February 2026, right? Now, in this course, I have divided the entire syllabus into 15 lectures. There are 15 lectures. The entire syllabus is divided into these 15 lectures. But students, these 15 lectures are not time bound. Some lectures can go up to 3 hours and some can go up to 3.5 hours. Right? So I have kept this particular benchmark that 3 hours is the time that we are going to focus for each lecture, and 3 hours is good enough to cover one single module very comfortably. So 3 hours to 3.5 hours is going to be the duration of one lecture. And I'm going to cover 15 lectures here, where I'm going to completely cover the topic of science and environment. When I talk about science and technology alone, I'm going to divide the subject of science and technology into 6 to 7 modules. Like first module will be space technology. Why space technology? Just to give you a quick info here, if you try to look at most of the questions that have been asked in the previous exams, you will find that they have been asked from 4 to 5 modules of science. 5 modules are there from where maximum questions have been asked, right? Number 1 is space tech. This is how I have divided the entire subject also. Second is energy technology. Energy technology basically includes everything, guys. Not just the topic of nuclear energy, solar energy, it covers all possible details that are there in the current affairs of energy technology. I have also covered nuclear energy, solar energy. You know that last year for the first time we have come up with our own geothermal energy policy. For the first time, Government of India has come up with a policy for that, right? So everything that could be a part of energy tech is covered in this second module, and you can expect questions from here. The third part of the discussion, or the third part of our science and tech module would be, it will be communication and frontier technology. You guys know that there is already a global index on frontier technology that is made by UNCTAD. UNCTAD already publishes the global, frontier technology index, right? And what does frontier technology actually includes? It includes, right, guys, the cutting edge technology, what you often call as deep tech, right? Deep tech startups, the companies, the organizations which are working in the area of AI, quantum computing, blockchain, right? These sort of things. Nanotechnology would also be included under frontier tech, but I've put nanotechnology in the separate module. Right? I'm going to cover nanotechnology in a separate module because I can easily relate communication and frontier technology together. When I talk about communication technology, I'll be talking about 5G, 6G vision of India, right? And then you have heard of something called as semiconductor, India semiconductor mission. All those things will cover it here, right? So this is going to be the third part of our module. The fourth part of our module is going to be biotechnology. Now students, every year without a doubt UPSC asks questions on biotechnology, biology, biotechnology. So of course this is because focused primarily on current affairs, we may not see a lot of information on biology in this. So I'm hoping that students who are taking up this course already have read these basics of the of general science. They have already read. Although I'm going to give small revision also. It's not like I'm not going to talk about any of these things. I'm going to give you small revision, some revision inputs also I'll be offering in between the course, because to make you understand biotechnology better, we have to understand at least the basics of genetics, right? So biotechnology is going to be the fourth module, and the fifth module would be nanotechnology and defense. Nanotechnology and defense, I have clubbed both of them together because both of them are otherwise small topics, right? Defense technology and nanotechnology, right? So this is how I'm going to cover the 5 modules, and you will notice students that most questions are asked from these 5 topics only. Mostly you will see questions are asked from these 5 topics. Nanotechnology defense is going to be the next topic. I hope all of you get it. So mostly you will find questions from these 5 topics only. I hope all of you guys are able to understand. And apart from this, apart from all these discussions, this is going to be the entire separations of module, and this is how I'm going to cover the entire subject of science also in possibly 7 lectures. There are around 7 lectures that I'm going to take on science, and these are the 5 topics that I'm going to cover, right? I have divided the current affairs based on these 6 in these 5 modules format only, right? This is how I'm going to cover up the topic of science. Now when I talk about the subject of environment, for environment I'm going to use the same. For environment I'm going to follow so students, for environment, when I'm talking about in the subject of environment and ecology, if you look at the questions that are asked, you will find that there are total 5 modules from where UPSC asks questions in the subject of environment as well. Those 5 modules are, here I'm going to first talk about the areas or the topics in which you will find questions. So you will find questions from the topic of species, right? When you talk about species, questions are asked related to the nature of the species, the ecological niche of the species. Ecological niche is basically physical or functional position of an organism. Questions are asked from that particular region, right? Questions can be asked between comparison of different species. Questions are asked between their conservation status, right? Questions can be asked from this particular section. That is one area from where UPSC asks questions. The second area from where UPSC asks questions are various issues related to ecology and environment. Like one issue is climate change, the issue of climate change. Another issue is the issue of pollution. Now when I talk about pollution, guys, you guys can understand everything related to pollution is covered under this particular domain, right? So I'm not going to differentiate between water pollution, air pollution, marine pollution, right? Thermal pollution, everything is plastic pollution, everything is part of this only, right? Then there are issues somewhat related to loss of biodiversity, right? Loss of biodiversity, ecological degradation or ecosystem degradation, you can say ecological degradation, right? So these are the sort of issues from where UPSC can ask questions. When I talk about loss of species, loss of biodiversity is going to cover up that part. Then students, the third area from where UPSC asks questions, it is from the topic of species issues, then Indian initiatives. The initiatives that India takes. This is the third area from where UPSC can ask questions. Indian initiatives. Indian initiatives mostly include environmental laws in India, right? Various environmental laws, and nowadays we are getting questions on environmental laws quite often. One of the primary reason for that is there are some changes being brought into environmental laws. You guys already know about the controversial, this controversial law on, this Forest Conservation Act, which has been now changed to Forest Conservation and Promotion Act, right? Then guys, some other schemes and programs, like you all have heard of Project Tiger, Project Elephant, Project Hangul Stag, Project Great Indian Bustard. There is a list of various programs that Government of India has come up with. I'm going to give all these things holistically to you, right? Indian initiatives. We'll talk about the initiatives that are in the current affairs. Then students, apart from this, the fourth area from where UPSC asks questions, it is international initiatives, right? Various international initiatives that are there. And under this you can expect questions on international treaties, right? Various treaties are there, conventions are there, international conventions, right? Conventions, treaties, like you must have heard, last year we have completed 50 years to CITES Convention, Convention on International Trade in Endangered Species. 50 years we have completed for that. You can expect questions related to this. You can also expect questions here related to Convention, International Treaty, and also various other reports, international reports that are published on environment, various indices or index that get released for environment internationally. Where does India stands? Which organization is publishing those things? All those things you can talk about, and UPSC can ask questions related to that. And last area, the last topic from where UPSC asks questions in the subject of ecology, it is from locations. Locations, right? The various locations related to the locations of protected areas, right? Locations like Ramsar sites, very famous. Locations like biosphere reserves, right? There are a lot many other things, important coastal and marine areas, important bird areas, lot of such locations are there. Biodiversity heritage sites, all these locations are here, right? These are the 5 topics from where you can expect questions in the civil services exams from the subject of environment and ecology, right? Now how I have divided this subject here, so you can see that there are 5 divisions on the subject of science and technology. I have divided the entire syllabus on this in this way. And secondly, I have also divided the entire syllabus for environment. First, I am going to start with climate change. Climate change is going to be the first topic. Why guys climate change? Because undoubtedly this is the most important topic in the subject of ecology and environment. Most of the discussions internationally, nationally are related to climate change only. But you guys can understand that climate change is not the only issue. It is basically an umbrella issue that can trigger other kinds of issues, right? So the second topic that I'm going to talk about are conservation issues, right? Conservation related issues, right? Here we'll not just talk about the issues related to conservation, but we'll also talk about some initiatives that have been there which are related to the conservation. Then third topic of our discussion would be issues related to ecosystem degradation. Sorry, not ecosystem, environment related issues. Environment related issues is going to be the third area. See, conservation related issues would include things like biodiversity degradation, loss of species, loss of biodiversity. Conservation would include related to environmental laws, right? Like animal related laws, forest related laws. These are basically conservation related issues, right? I hope all of you understand. But when I talk about environment related issues, this will include issues like pollution, mostly guys pollution, or laws related to pollution like plastic waste, e-waste, all these kind of things, right, etc. All these things would be part of the third part of our discussion in environment. Then guys, the fourth part of the discussion, it would include topics such as international initiatives. Whatever international initiatives are there in the last 1 year, whichever were there in the news, I'll talk about them, right? And lastly, I'll talk about the Indian initiatives. The Indian initiatives related to ecology and environment, right? Whatever Indian initiatives were there in the past 1 year, right? So remember the time frame, students. All these topics I'm going to cover from the time frame of 1st of January 2025 till 31st March 2026. This is going to be the entire scheme of coverage, and this is how I have divided the entire subject of ecology environment. So this is how that course is going to cover everything. Now the question is, what are the things that you are going to get when you join this course? You will get, first thing is, when you join this course, the first thing that you would receive, these are the deliverables, right? If you join this course, number one is you will get lectures, 15 lectures. Of course, student, these are going to be pre-recorded lectures, right? I'm going to record them on the same day of upload, the lecture as per the schedule given to you. On the same day I'm going to record this. So today is 10th of February. I'm recording it on the date of 10th itself, right? And guys, so you will get the 15 lectures. Then apart from this, you will have written notes, basically written or printed notes. These notes would be in the form of annotated PPTs of the class, whichever I'm using, plus their annotations plus PPT. This is what you get. And secondly, you will also have some kind of study material, right? Some of those topics which I think are important, but I have not taken them in the class, I'm going to simply put them in the form of some study material. It will also have the content that is there in the PPT. So students are requested to go through either the PPT or the study material. You will find something at some additional content, right? PPTs with annotations plus the study material. Study material will include all written material. It also includes all the written material of the PPT, right? So whatever written material of the PPT is there, you will find it in the study material itself, right? So it will be in the form of A4 printed sheets that you can download easily in the PDF format. You can find it, right? So all the material that is there in the PPT will also be there in the study material. You guys can simply read the study material and can follow with the classes, follow with the lectures, right? Now along with this, I will also be giving you some practice questions. Some practice questions also I'm going to share with you. They will be part of the study material only. Approximately 100 to 300 questions I'm going to target, right? Which will include all topics of science and environment. 100 to 300 questions. This is what you're going to receive. So every student joining this course is going to get all these deliverables, right? And this is what is basically is being offered in this course. So students, in the initial format, I had to talk about whatever things we are going to provide. Now students, let us start with our topic of discussion. Okay, so because I'm starting with the topic of science and technology first, and then we'll move on to ecology environment. One more point here, because today is 10th of February. Today is the date of 10th, right? Today is 10th of February, students. But I have made a commitment that I'm going to provide you the current affairs till 31st of March 2026. So students, if you look at the lecture plan, you will find out that I'm going to take one additional class that will be on in the first week of April. So whatever current affairs I could gather till 10th, till today, or for being on the safe side, I'll say till 31st of January today. Till 31st of January, whatever current affairs I could gather, I have put up those current affairs in 10th of February class, you can say. So when the next class would come up on 12th of February, you can say that I would record if anything necessary or if anything relevant comes in this past, 12 days or 10-12 days. So every lecture is being updated, right, on a timely basis. But what about the current events that may occur in this coming month or in this coming 2 months, from 1.5 months technically from today to 31st of March? So for those current events, I am going to take the last class that will be in the first week of April. In the first week of April, I'll talk about all current affairs that would have happened, by 31st of March. if anything is relevant to us. I'm not going to take up any random current affairs, but if anything that seems relevant to our discussion, we'll take up those points from those important information, right? And the last class would be somewhere in the first week of April, right? First week of April, I'm going to come take the last class and finish the entire course. Okay, students, my personal objective is basically to help you guys in such a way so that you don't have to look for multiple sources, especially for the subject of science and ecology. So I would highly request that now, if you are part of this course, follow the course very diligently, take up the subject of science, study everything related to science on the day itself. So I would, because I'm going to record this video from, you can say, somewhere around 1 p.m. to 6 or 7. In between that time slot, I'm going to record this, because before that I have another class to take. So between 1 to 6, I will be recording this video, and somewhere around 8, I would be sharing the entire link with you, right? So when everything, all the rendering, everything is done, I'll be sharing the link with you so that you guys can easily, read, listen, look at the entire lecture on the very same day. You can use that particular day for the subject of science and environment, right? So if there are 15 lectures, use those 15 days to study everything related to the subject, so that other days you can concentrate on other subjects. If you think your polity is weak, work on polity. If you think history is weak, work on history. If you think economics is weak, work on economics. Work on all these areas, but for science, leave it for these 15 days, right? Science and environment, leave it for these 15 days. If you are struggling much more than this, then leave one more day additional. So 15 plus 15, 30 days. 30 days, and you should not be investing more than this to cover the entire subject here. So whatever things I'm going to cover in the class, do understand them, right? You already have my WhatsApp number. The number is already being shared with you. You can connect with me on this particular number here, right? It is 9667382273. I'll be available on this number. You can ask questions, ask queries. I'll be happy to answer them. And eventually, do not spend more than 30 days for this particular subject here. We should be preparing the subject with that level of confidence that we are able to handle all sorts of questions, right? And whenever you get the practice questions to answer, whenever you get the practice questions, use the practice questions, answer them, right? Share the feedback with me on my WhatsApp, although the practice questions will also have the answers along with it, but make sure that you are reading it, practicing them, right? So that you're able to understand and answer the questions easily. All right. So now students, let us start. Let us start with our discussion. So this is the entire breakup of the topic, right? The miscellaneous class, this is going to happen in the first week of April, right? Whatever is there that requires our attention, we'll talk about it. And by the first week of April, we'll be completing this particular section, right? These are the 5 topics you guys can see. I have already told you about. These are the 5 topics. The first topic that I'm going to start today. So lecture number 1 and 2, I'm right now recording lecture number 1. Lecture number 1, it will be uploaded on the date of 10th of February, right? So here, as I'm recording first lecture on 10th of February, the second lecture I'm going to record on 12th of February 2026. Okay, so this is the date of upload, and the link is going to be shared to you, and you guys can start preparing along with it. So now starts with the first topic. The first topic of our discussion. Now, the first topic that I'm going to take is space technology, right? Today we'll talk about the part 1 of space tech. In the part 1 of the space tech discussions, I'm mostly going to focus on space debris, launch vehicles, because they were in the news last year. And I'll also going to focus on the topic of, lunar space missions, space policy of India, and the lunar space missions that were in the news. Okay, this is going to be the focus area of my discussion in this class. So students, the first topic of our discussion is related to space debris. Let's start without wasting any time. Space debris. Now, what exactly do we understand by space debris? What is the function of space debris? Let's look at it quickly. So students, space debris basically means any kind of man-made, non-functional, junk satellites, right? Disengaged components of rockets, disengaged components of rockets or junk satellites, these basically are considered as space debris, right? Or if any kind of wreckage that is left in space, right? That is left in space, we consider it as space debris. So space debris basically includes non-functional junk satellites, disengaged components of rockets, or any sort of wreckage that is left in space, right, by us. We consider that as space debris. Now, to understand more about space debris, it is important for us to first appreciate where is the debris found, where is the space debris found mostly. So students, if you look at the distribution of space or distribution of space debris on Earth, it is more important to first look at where are the various orbits where satellites are normally deployed. So imagine students, if this is the surface of the Earth, let's suppose this is the Earth's surface. The first orbit where satellites are mostly deployed, this orbit is called the lower Earth orbit. Lower Earth orbit. This orbit normally ranges from 300 kilometers and can go up to 1500 kilometers. In some books it says 2000 kilometers also. You can write 2000 also, right? 300 to 2000 kilometers, because some books they often mention 300 to 2000 kilometers also. You can consider 2000 as well. Okay, because there are some satellites which are lower Earth orbit and they have been deployed in 1700 kilometers, right? This is lower Earth orbit. Then students, the second orbit where satellites are usually deployed, it is called the middle Earth orbit. Middle Earth orbit ranges from 5000 kilometers and can go up to 12,000 kilometers, right? And the third orbit where satellites are deployed, it is called the geosynchronous Earth orbit. Geosynchronous Earth orbit, and this is located at a distance of 35,786 kilometers. These are the three orbits and these are the three respective distances. Now students, when you talk about space debris, most of the space debris is located at the lower Earth orbit only. It is the lower Earth orbit that is mostly exploited by space debris, because it is quite obvious guys, any country that will try to reach space would first try to capture the lower Earth orbit. कोई भी country अगर space में जाएगा तो it will first try to capture the lower Earth orbit, right? It will first try to capture the lower Earth orbit, and that is why lower Earth orbit significantly has a high number of satellites, right? In fact, if I just talk about lower Earth orbit for a while, you will notice that lower Earth orbit satellites, these satellites are like, just to give you a quick information that how many number of satellites are there. So just Starlink, if I talk about Starlink is the famous Elon Musk satellite for satellite based internet service. Starlink alone has approximately 4000 satellites, and all of them are in the lower Earth orbit. Starlink alone has right now over a network of 4000 satellites, and their actual plan is to put around 12,000 satellites. So their number is going to increase by 3 times from here, right? So Starlink already has this many satellites. Then students, when you talk about satellites meant for remote sensing, satellites responsible for taking images of Earth, imaging, satellite responsible for spying. All of you guys know about RESAT of India, right? HISIS is hyperspectral imaging satellite. Just as an example, I'm writing it here. Imaging, spying, right? If you want to put satellite for mapping applications to create the right or accurate mapping, all these satellites are supposed to be launched in the lower Earth orbit. Lower Earth orbit satellites are very popularly known for it, right? Of course, guys, remote sensing is also, weather forecasting is also remote sensing, right? So there is one exception here that you should know, that geo Earth orbit is mostly popular for weather forecasting. Most of the satellites meant for weather forecasting are put in the geo Earth orbit. This is also a type of remote sensing only. Weather forecasting is also a type of remote sensing. Okay, and along with that, geo Earth orbit, it is also, you know, popularly used for communication, right? So it is also popularly used for communication as well, right? All your Tata Sky, these dish TVs, they were all working on geo earth orbit satellites. Okay, so communication also it's popular. But now with Starlink, it is quite obvious that lower earth orbit is also very popular for internet broadcasting and communication, right? Okay, so this is basically is the distribution of the lower earth orbit. So most satellites have been placed in the lower earth orbit. But students, there is a problem with the lower earth orbit. The lower earth orbit is fairly close. It is very close to the earth's surface, just 300 kilometers from the earth's surface. So despite of being the most popular orbit, lower earth orbit also faces a challenge. And the challenge is that lower earth orbit offer a very short service life for a satellite. Satellites, they have a very short life in the lower earth orbit, usually ranging from 3 to 5 years. 3 years to 5 years is usually the life that a lower earth orbit satellite can sustain for. The reason is simple, because in a lower earth orbit, when it is just 300 kilometers from the earth's surface, it is difficult for the lower earth orbit to remain stationed forever, right? Because it has to burn a lot of fuel to keep itself located there, because earth's gravity is constantly pulling the satellite. So lower earth orbit satellites, they happen to be constantly pulled by the earth's gravity, and in order to keep them keep them located at the desired orbit, they will have to burn a lot of fuel. A lot of fuel is being burnt, and because a huge amount of fuel is being burnt, they end up having a short life. Their overall longevity is much shorter, hardly goes not beyond 5-6 years, right? Doesn't go beyond that. Then apart from this, one more thing is there. To keep itself stationed at the lower earth orbit, we also see these satellites running at a very high speed. Their speed happens to be very high, right? Satellites in the lower earth orbit run at a speed of approximately 25,000 kilometers per hour. 25,000 kilometers per hour. That's somewhere around 7 kilometers per second. 7 kilometers per second. 7 kilometers per second is an average speed of a satellite in the lower earth orbit. When I talk about satellites in the geosynchronous earth orbit, the satellites have a speed of nearly 3 kilometers per second. 3 kilometers per second. That is the speed of geo earth orbit satellite orbits, right? 3 kilometers per second. But for lower earth orbit, it goes up to 7 kilometers per second, right? And when something is traveling at such a fast speed, when something travels at such a high speed, a lower earth orbit satellite takes around 90 to 120 minutes. It takes around 90 to 120 minutes to complete one orbit. 90 to 120 minutes it takes to complete one orbit of the planet Earth. To complete one orbit, it takes 90 to 120 minutes. So it clearly shows that lower earth orbit, these are the characteristics. By the way, one more thing I should tell you, which I'm also hoping that UPSC may ask. Lower earth orbit also have the International Space Station. The International Space Station is also located in the same lower earth orbit, and you guys know that very recently this Axiom 4 mission that was sent. I'm going to talk about Axiom 4 mission also, students, in the class, because there could be a question. It was just the second time India has sent an astronaut to space, right? I hope you understand. There have been other Indians who have been to space, but all those Indians who have been to space, none of them were Indian citizens, apart from squadron leader Rakesh Sharma and the flying I think he's of captain rank, if I'm not wrong, the flying captain, this Sudhanshu Shukla, right? So these are the two Indian Air Force officers who have been to space. This is just the second time India has sent an astronaut with this Axiom 4. So we'll talk about Axiom 4, what has been India centric research, what have been the research that was sponsored by India, performed at International Space Station. We'll see that. So students, this is the brief introduction about the lower earth orbit, and lower earth orbit is having most of the space debris. Most of the space debris is concentrated at the lower earth orbit, right? So most space debris is found at the lower earth orbit for obvious reasons, students. Just in 5 years their service life gets over, so they become debris. They run out of fuel, and then they eventually start draining out their batteries and they eventually become debris. Then their speed is also quite high. So just imagine if the satellites are moving at a very high speed, and that too without any control, without any regulation, that's where it becomes a challenge. That's where they can hit any active payload and cause a massive swarm of debris collisions, right? So this is basically is the characteristic of the low Earth orbit and the meaning of space debris. Now students, when we talk about why space debris has been in the news, so remember students, before I go ahead, it is important to know why are we talking about it. So students, what has happened last year, China has sent a mission called Shenzhou 20. These were basically astronauts that were returned to Earth after the debris strike had occurred in the orbit, causing a delay in their scheduled return, right? So basically what happened, this Shenzhou was basically a mission. It was basically a mission that was being sent to the Chinese space station. If I talk about space stations, there are right now 2 space stations working. Both of them are in the low Earth orbit. One is the US led International Space Station. You guys know that Russia is also part of it, but Russia, as per the official records, in 2025 it has left, right? Although Russia was also a part of it, right? Then there is a Chinese Tiangong mission, right? Tiangong is another space station. These are the 2 space stations that are there right now, working space stations. Russia also had their own space station. In fact, the first space station was made by Russians only, called Salyut, and the latest space station that Russians had was called Mir, right, which was there till 1998, and then it eventually completed its life, right? So what happened, students, this particular space, why we are talking about space debris, because Chinese astronauts, they were made to return to Earth after a debris had struck the orbit, right, which caused a delay in their scheduled return, right? So basically they were supposed to return, much early, but they safely returned to Earth, but their return got delayed because of a space debris that has stricken the orbit, and it was moving in the orbit. It was not possible for any event of bringing the astronauts back from their Tiangong space station. So there was a delay in their return to Earth. Maximum debris concentration that we see, it is noted at the altitude of 800 to 1000 kilometers and nearly in the 1400 kilometers range. That means maximum of the space debris we see is in 1400 kilometers range, which is in the lower Earth orbit, right? And if you talk about the current status of the space debris, there are approximately 1 million pieces. There are approximately 1 million pieces of space debris that are larger than 1 centimeter are in the Earth's orbit. Larger than 1 centimeter are revolving in the Earth's orbit, causing catastrophic damage to space assets and rendering some orbits entirely unusable. Students, you must have heard, I have also talked about this in the foundation courses. There is something called Kessler syndrome. Kessler was actually a NASA scientist. His name was Donald Kessler. Don Kessler also, he is famously known with the name. In 1978, Don Kessler, he gave this idea, or he gave this concept of Kessler syndrome. What is this Kessler syndrome, guys? Kessler syndrome simply talks about, it simply talks about crowding of the lower Earth orbit. Crowding of the lower Earth orbit with space debris. So students, just use your common sense. If we keep on adding the space debris, if we keep on putting a lot of space debris in the lower Earth orbit, because every 3 to 5 years the debris starts, to form, right? The satellites become junk satellites. So every 3 to 5 years, after this, the satellites become junk satellites. It is likely that this debris is eventually going to fall back into the Earth. But guys, it takes almost 10 years of time, right? Even if the satellite becomes non-functional today, it takes approximately 10 years for the debris to fall back. It takes approximately 10 years for the debris to fall back and burn in the atmosphere. Right? To burn completely in the atmosphere, it takes around 10 years for this debris to fall back and burn in the atmosphere. So Kessler syndrome basically talked about a possibility. It talked about a possibility of a chain reaction. A possibility of a chain reaction of collisions. Right? He talked about a possibility of chain reaction of collisions. Basically, he said that if this debris, if we keep crowding, if we keep putting a lot of satellites in the lower Earth orbit, the lower Earth orbit will keep getting crowded. And once the crowding exceeds a certain threshold, these junk satellites may start hitting each other. And all of you understand space debris are moving at a very high speed, 7 kilometers per second. So these junk satellites will start hitting each other, and as they hit each other, they would create a massive swarm of debris. It would create a massive swarm of debris. And this swarm of debris would essentially travel all along the lower Earth orbit and would start destroying anything that comes on its way. Anything that comes on its way, it will start taking them down, it will start destroying them, and eventually making the entire lower Earth orbit unusable for any active satellite. It will make the entire lower Earth orbit completely unusable. That's what the Kessler syndrome is all about. Okay, it creates a swarm of debris in this region. I hope all of you guys are able to understand. This is what is the problem of space debris. Okay, now students, when there is a discussion on space debris, now it is important to see what are the possible initiatives to sort out, to solve the problem of space debris, right? So let's talk about the various efforts that has been taken up internationally and both domestically. So first we'll talk about the international initiatives, right? The international initiatives that are there to reduce space debris. What all international initiatives are there? Let's talk about them. The first initiative is, there is a satellite that have been made called Remove Debris Sat. Remove Debris. It is a satellite, guys, Remove Debris Sat. It was made jointly by University of Surrey. Surrey is in UK, guys. Second is International Space Station and SpaceX. All these three organizations, they tried to develop a satellite called Remove Debris Sat, and the purpose of this satellite was active debris removal, ADR. Active debris removal. Active debris removal means capturing the debris plus deorbiting the debris. We do not want this particular debris to remain in this orbit. Capturing and deorbiting the debris. The first one is Remove Debris Sat. Then students, the second initiative is European Space Agency. European Space Agency has started one initiative called Clear Space 1. Clear Space 1. Clear Space 1 is a joint venture having the same objective, guys. ADR. This will also perform ADR. It is expected that this Clear Space 1 is going to be launched this year. In 2026, we may see the Clear Space 1 to be launched. By the way, Remove Debris Sat was launched initially in 2018. In 2018, this Remove Debris Sat was launched, right? Clear Space 1, 2026, it is going to be launched, right? This year itself. Then students, there have been other initiatives also, like Japan, JAXA. Japan has built a satellite called LignoSat. LignoSat is world's first wooden satellite. It is the world's first wooden satellite, right? Why wooden satellite? Because we all know wood happens to burn much more easily. It's very sustainable. So if we make a satellite made up of wood, then it's very likely that this satellite may fall back into the earth, and as it falls back into the earth, it may burn out completely. It may completely burn out and would not cause any kind of damage, would not cause any kind of harmful residue. Harmful residue would remain in the earth's atmosphere, and it is completely sustainable. So to find sustainable material is also a problem, is also a concern. See, understand this. When I talk about debris, when I talk about space debris, students, we have to consider few points here. The number one point is we either have to make our satellites reusable. We can make satellites reusable, right? So that the satellite can be brought back or their life can be extended by refueling them. So reusable sats or reusable rockets. In this way, the debris can be reduced in future. In future, we will see satellites which are able to work longer will not be having a short life of just 5 years. They may be able to work for 15, 20, even longer than that, if refueling is possible. And then the reusable rockets also. The rocket should put the satellite up in space and then come back and should be ready for the next mission. That is another way of reducing space debris. And the third way is basically capturing and removing the debris that is already there, right? ADR, capturing plus deorbiting it, right? Removing the debris. Okay, so we have to follow all these three possibilities. So if you can make satellites more sustainable, that's also better. If you can capture the satellites which debris that is already there, that is also good. Both the possibilities are there. Okay, so these are some of the initiatives. Then students, these are some other initiatives that UPSC can ask. UPSC can ask these initiatives also. Like for example, there has been a recent initiative called Zero Debris Charter. UPSC can ask these sort of things straight away. What is Zero Debris Charter? It is basically a group of 12 nations plus European Space Agency that is committed to become debris free, debris neutral by 2030. Debris neutral by 2030, focusing on safe operations and end of life disposal and sustainability standards. Focusing on safe operations, end of life operations, disposal and sustainability standards. Please give me a moment, students. All right. So students, when you talk about this Zero Debris Charter, so European Space Agency has committed to become debris neutral by 2030. Debris neutral means whatever debris they leave in space, they will have to capture it and they will not add any new debris, right? They will become debris free by 2030. This is what is Zero Debris Charter of 2030. Remember students, it is an initiative of European Space Agency with 12 countries. These 12 countries are also European countries only. ये EU की countries and these are European countries only which are part of this initiative. But students, the question is India a part of this initiative? So students, India is not part of this. India has not joined this initiative, right? But if India has not joined this initiative, is there something similar to that in India? So India is not a part. India is not a part. But students, interestingly, as per our space policy 2023, India also have an objective of becoming debris free. India is also having an objective of becoming debris free by 2030. India also has having an objective of becoming debris free by 2030. That means by 2030 onwards, all space missions of India have to be debris free space missions. Okay. So it's called debris free space missions 2030. All space missions are going to be debris free. So India is not a part of this initiative, but we also have a policy of making our country debris free by 2030. This is what we have under the Zero Debris Charter, another international initiative. Then guys, United Nations Global Governance Mechanism. So students, there is something called UNCOPUOS. What is this UNCOPUOS? This is basically stands for, chalo, let me give you the background of this also. Do you have any extra blank slides here? Okay. All right, let me talk about it here. So students, when you talk about space, technology, just like any other field that is internationally known, there are usually some international treaties regulating it, right? You guys know that we have the United Nations regulating laws of the oceans, laws of the sea. So we have United Nations Convention on Laws of the Sea. We have United Nations talking about climate change. So we have the United Nations Convention, Framework Convention on Climate Change. There are United Nations Convention on Labor. There are United Nations treaties on various issues related to the people of the earth, right? Related to the entire global community. When it comes to space, there is a treaty called Outer Space Treaty. This treaty, Outer Space Treaty, it was actually signed in 1967, right? It was actually signed in the year 1967. Okay, and this particular treaty here, please wait a moment, right? This particular treaty here is, student, just give me a moment, please. All right, so there is an Outer Space Treaty, students. Outer Space Treaty is basically, it was signed in the year 1967. Remember, what is outer space? Suppose if this is planet Earth, this is the planet Earth, nearly 100 kilometers, approximately 100 kilometers from the Earth's surface, there is an imaginary line. There is an imaginary line, we call it von Karman line. There is an imaginary line called von Karman line. This von Karman line is considered to be the dividing line between airspace of a country and outer space. Now, under the von Karman line, we consider it as airspace, where countries can make their own law, countries have their own legal system working, and when you cross the von Karman line, we enter into outer space. And for outer space and its affairs, we have the Outer Space Treaty. So von Karman line is there, and this von Karman line divides the airspace with outer space. 1967 is the time when this Outer Space Treaty was introduced. So all aircrafts, everything flies within the airspace, right? All aircrafts, they fly within the airspace. When you cross the airspace, you enter into the outer space. Okay. Now this is the Outer Space Treaty. India is a member, guys. India is a signatory member. In 1982, we have ratified Outer Space Treaty. हमने ratify कर लिया था. So now we are a full-fledged member of the Outer Space Treaty. 1982 we ratified it. Okay. Now India is a member of Outer Space Treaty. So to look at the Outer Space Treaty, whether it is being applied, United Nations, this is a treaty under United Nations only, right? So United Nations, to see the working of the Outer Space Treaty, to see its implementation, Outer Space Treaty have something called United Nations Office of the Outer Space Affairs. So under this treaty, United Nations have established a separate office for all outer space affairs. So outer space, we have understood what is it. So there is something called United Nations Office of the Outer Space Affairs. This is located at Vienna, which is the capital of Austria. Office of the Outer Space Affairs. Now this Office of the Outer Space Affairs, they organize something called United Nations Committee, United Nations Committee on Peaceful Use. So there is a committee, not organized, there is a committee called United Nations Committee on Peaceful Use of Outer Space, which is written in acronym as UNCOP UOS, United Nations Committee on Peaceful Use of Outer Space. So as per the UN Committee on Peaceful Use of Outer Space, so this is a committee, it's a permanent committee under United Nations Office of the Outer Space Affairs, UN Committee on Peaceful Use of Outer Space. As per this committee, they have come up with guidelines in 2007. In 2007, they have come up with some guidelines regarding who is going to take responsibility if a debris damages some other country's infrastructure. So let's say, for example, if there is some space debris that has been created by India, So some Indian satellite which has stopped working, and unfortunately this satellite hits a working satellite of some other country. It could be China, Russia, USA, any other country, and it hits that working satellite. So who is going to be held responsible? So there is something called United Nations Committee on Peaceful Use of Outer Space guidelines in 2007. Similarly, guys, in 1972 there was a liability convention on space debris that was signed. I have covered the liability convention here itself. Convention for International Liability for Damages Caused by Space Objects, 1972. This is the convention, right? Then students, there is registration convention on space debris, 1976. All these three initiatives have been there in order to strengthen sharing of information, sharing of data regarding space debris, and also setting accountabilities for any damages. Who will be held responsible for any damages? It will be these three conventions that are there. Okay. Then students, like I told you already, there are some other active debris removal missions, like Japan is planning ADRAS-J, which is a Japanese mission, Clear Space 1 of European Space Agency, and UK already has tested removed debris test nets, right? Then there are some magnets, robotic capture systems, right? They all have been designed internationally by various organizations in order to find ways of capturing the debris and removing them. Active debris removal, right? Then students, NASA has come up with a project called Orbital Debris Program. This Orbital Debris Program is a tracking system that NASA has developed, right? A tracking system that has been developed by NASA to track the movement of this orbital debris. European Space Agency has also come up with their own tracking network. Then there is a global surveillance system that is being developed, which is going to monitor more than 1 million debris pieces to prevent any collisions, right? We have to avoid any possible collision of this space debris. We have to avoid any possibility of, this Kessler syndrome to happen, right? This is what we have under the efforts to curb space debris. Got it? Then students, India has also taken some initiatives. We'll talk about the Indian initiatives later. So these are the various initiatives that are there related to space debris, right? International initiatives. These are international initiatives. Now students, if I talk about Indian initiatives, so first let us try to understand how is India responsible. So if I talk about Indian initiatives, let us first observe how is India responsible for debris. India responsible kaise hai? So India is responsible for debris. Firstly, our satellites, after their service life, they become junk. So junk satellites is one way how the debris will be formed. Second is our rockets. Their components are there. Rockets components are there. These rockets components, they create a problem because these rockets components will get disengaged while taking a satellite up in space, and then once they get disengaged, their components become space debris. And thirdly, our wreckage. See, ISRO is a very successful organization today, but there is a lot of wreckage that is still formed. Like that the previous two missions of PSLV C61, C62, they both have failed. So there could be some debris formed and there could be wreckage left from these space missions, right? So India is basically responsible for all these three things, how it can constitute or how it can add up to the space debris. Now what all possible solutions we can think of? So India has come up with a series of solutions. First solution is we have tried to improve our rocket technology. Number one is we are working on making a reusable launch vehicle. Guys. This is the first thing that we are doing. We are working on making a reusable launch vehicle. A reusable launch vehicle basically means it's a launch vehicle that will be reusable. That means this will take satellites or take objects to the space and will come back and would be ready for the next mission, right? We are calling it RLV. Its prototype is already ready. Its prototype name is called RLV TD. TD stands for Technology Demonstration Pushpak. So we have given a new name to this particular launch vehicle, RLV TD Pushpak. This is going to be our first reusable launch vehicle. We have already tested this reusable launch vehicle in multiple conditions. So this is already in the pipeline. Then second is, we have improved the PSLV. PSLV is called Polar Satellite Launch Vehicle. It is one of the launch vehicles of India, most popular launch vehicle of India in fact. And we have introduced something called POEM, Polar Orbiter Experimental Module. I'll talk about POEM shortly, guys. Right? POEM is Polar Orbiter Experimental Module. Polar Orbiter Experimental Module, what is the meaning? Don't worry, I'll talk about it just in a short while. Then students, we have also working on another launch vehicle called NGLV. NGLV stands for Next Generation Launch Vehicle. Next Generation Launch Vehicle is going to be partially reusable launch vehicle. It's going to be a partially reusable launch vehicle, and it is expected to be ready. Partially reusable launch vehicle. Reusable launch vehicle, and it's expected to be ready by 2032. We are already working on it. It's going to be ready by 2032, right? Then students, there is also one more mission that we are working on. It's going to be a lunar launch vehicle, a lunar module launch vehicle, LMLV, lunar module launch vehicle. But this lunar module launch vehicle, I'm not writing it here because it is likely to be ready by 2035. Lunar module launch vehicle, but it has been dedicatedly being made for lunar missions, for moon missions. So when we'll talk about lunar missions, I'll talk about lunar module launch vehicle of India. Today only we'll talk about lunar missions also. All right. So these are the three things that we are doing in the rocket technology. Then second part is, in order to improve surveillance, we are working on initiatives like Project Netra. ISRO have started something called Project Netra. Project Netra is our premium surveillance initiative, right? And under this Project Netra, we have also set up something called Space Situational and Awareness Control Center. Space Situational and Awareness Control Center. Space Situational and Awareness Control Center. This can actually help in monitoring the space situation better and see if there is any possibility of space debris hitting us, hitting our active payload or not, right? And also can prevent any of our debris to hit the payloads of other countries, right? Surveillance. Then the third part of the initiative here is, when it comes to some novel technologies have also been developed in India. One technology is SPADX, space docking. SPADX. It's called the space docking experiment. SPADX is space docking experiment. So basically this means, all of you must have heard, India has become just the fourth country, last year only, India has become just the fourth country to perform space docking. So space docking or simple docking means bringing two payloads or two vehicles side by side. This is something which has been practiced since a long time for ships. You know, whenever you want to transport materials inside, outside the ship, whenever you want to transport people inside, outside the ship, you will simply bring two ships or two vehicles next to next and standing simply abreast to each other, and then you will connect them with a physical, with a physical connection. It could help you to transfer fuel from one ship to another, refueling on the ship. It can help you to transfer electricity, power, any kind of materials, or even people can be transported from one ship to another. This is a simple concept of docking. Then students, as the technology advanced, we were able to perform docking in aircrafts, flying aircrafts, wherever we wanted to do refueling of fighter aircrafts. We could take the fighter aircraft in the airspace. Another larger aircraft will come closer, which will do the refueling. It will connect the two aircrafts together. They will be docking next to each other, and then they will be, sharing or transferring fuel from one aircraft to another. Then students, if you talk about, so this was docking. Then guys, there is also something called space docking. Space docking is something which you basically do it in space, where two space objects comes next to each other and you transfer material, substance, fuel, everything from one spacecraft to another. This is called space docking. So when you talk about docking as such, space docking can actually help us in refueling of old satellites, right? So if the old satellites, but of course guys, every satellite may not be possible to refuel, but if you are able to dock next to a satellite, then we can actually perform refueling, and we can perform this refueling and eventually supply fuel or transfer fuel into the satellite, which can help it to extend its service life, right? This is one way of refueling the satellite. Then guys, under new technology, we have also developed something called Unnati. Unnati stands for Unispace nanosatellites. Unispace nanosatellites assembly and training by ISRO. Assembly and training by ISRO, right? This is basically an initiative to do assembly and training of nanosatellites, right, by ISRO, right? And it's a UN-led initiative. India is also part of this, Unnati. In this way, we can actually make satellites smaller and make them much more capable. We can make satellites smaller and make them much more capable, guys. Nanosats are smaller satellites. We generally have four types of small satellites that we consider. Nanosats are usually satellites of less than 10 kgs, right? Satellites of less than 10 kilograms are called nanosats. Okay, so this is another initiative that we have under this, right? So this is what we have under the simple idea of the initiatives that India has taken to reduce and remove debris in the future, right? Now student, there is something called POEM that I have not talked about. Let me talk about it quickly. POEM के बारे में बात करते हैं. So students, look at this. So if you talk about the Indian debris mitigation efforts, you can see ISRO has come up with this Netra surveillance system, which is basically to monitor space debris. Second is we have come up with this MOTR radar. MOTR basically stands for multi-object tracking radar. Multi-object tracking radar. And we have also participated in IADC. IADC, what is it? Let me talk about this as well. IADC, it's called Inter-Agency Space Debris Coordination Committee. This was established in the year 1992, right? It is basically a coordination committee of space agencies. It's a coordination committee of space agencies, guys. Inter-Agency Space Debris Coordination Committee. It is not a coordination committee of countries. Basically, ISRO is a member of this agency or this committee, and NASA, European Space Agency, French Space Agency, UK Space Agency, Chinese Space Agency, all of them are part of it. And they basically share information from one country to another whenever they would identify any space debris of any country moving and trying to hit other countries, right? Other countries' active payload. So this is IADC. So this basically provides information. So this is basically an information sharing, initiative where countries can easily help in detecting any space debris if it is there. Okay. So various space organizations together are helping each other, right? I hope all of you know this is also the objective of the Outer Space Treaty. Outer Space Treaty consider outer space as a global common. Outer Space Treaty is considered as a global common, guys, right? This is probably, I believe all of you guys remember in the foundation course we have discussed these things in a lot of extensive detail, because here I'm only talking about space debris, so I'm discussing all the initiatives that are there. Okay, so this is what we have. Now students, there was a news last year. So there were two news last year. One was related to the space debris incident of China, and the other one is if debris of space crashes onto Earth, who is really responsible? So we have already talked about it. We have the Interagency Space Debris Coordination Committee, which has set up space debris mitigation guidelines in 2002. Then we have the UN Committee on Peaceful Use of Outer Space, where they both have defined what is space debris. And students, the entire liability is usually given to the launching state. Launching state is basically considered liable for any of such damages. Launching state is responsible. So if Indian satellite debris has fallen onto any country, India would be held responsible for it. Launching state would be held responsible. Okay, remember this. Then guys, even if you talk about Article 6 of the Outer Space Treaty as well, as per Article 6 of the Outer Space Treaty also, it will always be the state. It will always be that states are going to bear the responsibility for both government and non-governmental initiatives. For both government and non-governmental initiatives, it is the state that will have to take responsibility for all space activities. Whatever is happening, both government and non-governmental state will be held responsible. So I don't think there is a need to talk any further on this. Remember these conventions. In conventions के नाम आपको याद होने चाहिए. You should remember these conventions. Convention for International Liability for Damages Caused by Space Objects, and also Outer Space Treaty. UPSC can pick up any of these things and ask as well. Right? So this is basically what we have under space debris and who is responsible. Now the question is what India has done. So I want to talk about POEM here. POEM, Polar Orbiter Experimental Module. Remember the full form of POEM is Polar Orbiter Experimental Module. So we'll talk about this initiative POEM, because rest of them you'll be able to understand easily. Right? So what is POEM? So look at this. Students, this is basically a very simple diagram representing the 5 rockets of ISRO. Out of these 5 rockets, 3 of them are still in service and they are very popular. Number 1 is PSLV. PSLV is the most popular rocket of ISRO, right? It is the most successful rocket of ISRO as well. Then we have the GSLV, although this image is GSLV Mark 1 and 2. This is GSLV Mark 1 and 2, right? GSLV Mark 1 and Mark 2. This is GSLV Mark 1 and 2. And then we have the LVM3. LVM3, which is also called GSLV Mark 3. GSLV Mark 3. Right? It is the same rocket. Okay. So these are the 3 popular rockets: PSLV, GSLV Mark 1 and 2, and LVM3 or GSLV Mark 3. Now, when you talk about PSLV, let's talk about PSLV first here. Our PSLV stands for Polar Satellite Launch Vehicles. Our PSLV stands for Polar Satellite Launch Vehicles. And when you look at the PSLV carefully, you will find that this is the place. This is the heat shield. Right, this is our heat shield, guys. Okay, this is our heat shield. So this is called the heat shield, and this purpose of the heat shield is basically to protect the payload. So the whatever payload is being carried is carried inside the heat shield, and this is your rocket core. This is your rocket core. And if you look at the PSLV, the first part of the rocket core, this is called the stage 1. Then this is stage 2, this is stage 3, and this is stage 4. This is how the 4 stages of PSLV are identified. Okay, I'm not getting into the lot of details. I'm just going to quickly talk about that. When you talk about the PSLV, the stage 1, 2 and 3 does not become debris. Stage 1, 2 and 3 does not become debris because these are the stages that will very quickly get detached from the from the entire rocket, and they will fall back much early. It is the stage 4. It is the stage 4 of the rocket that becomes space debris. Stage 4 is the one that becomes space debris, guys. And this stage 4, this is the one that eventually becomes space debris. Right? The stage 4 becomes space debris. Now the thing is, how are we going to manage this stage 4? So when India says that by 2030, we have to become zero debris space mission country, we have to become zero debris. So what India has done in order to avoid this stage 4 from becoming debris, what India has done to avoid this stage 4 from becoming debris is we have simply converted this stage 4 into an experimental module. we have converted the stage 4 into an experimental module. Experimental module means, see, when stage 1, 2 and 3 are going to be launched, when stage 1, 2 and 3 are going to be launched, these missions, these stages will eventually get disengaged periodically, and when the stage 4 is going to be powered, when the stage 4 is going to be propelling the rest of the payload to its orbit, it will essentially disengage and then become space debris. So what ISRO has thought, that why don't we put some experimental modules in stage 4 itself. So what they have thought, that they have redesigned the stage 4. It will be propelling the payload to reach its orbit, but once it will deploy the payload and once the payload will reach its orbit, after that the stage 4 will start behaving like an experimental module. It will start behaving like an experimental module, such as we can put some small modules of a battery system, and the battery system can be observed to see if how the battery system is working in space conditions. We can test new kinds of materials. We can take a small prototype of a material and put it here. We can test some technologies, like the POEM mission has carried a robotic arm which was meant to capture the debris and remove it. So we can test these small test modules, and we can simply fix them at the 4th stage of the PSLV, and that's how PSLV 4 stage can remain in our monitoring radar, and even after deploying the payload to its orbit, the stage 4 remains actively connected to us. We keep observing the stage 4. The stage 4 remains debris for almost 3 to 4 months. For 3 to 4 months it will remain revolving in space, and once after 4 or 5 months, when it falls back into the earth, we can retract the entire stage 4. We can collect the entire modules, we can collect the data of the modules and study them and find out if the modules have worked perfectly as per our requirements in space. So stage 4 is no more considered as a debris, and now when the stage 4 returns and falls back into the earth, it leaves no debris in space. So technically PSLV is still not a reusable rocket. It is not a reusable rocket, but now PSLV does not leave any debris, which was not the case in the previous launches, where POEM was not there, Polar Orbiter Experimental Module. Got it? So this is how ISRO has been able to reduce the debris in future. So they have reduced the debris of PSLV by simply switching to a Polar Orbiter Experimental Module instead of a simple 4th stage of the PSLV. So students, these are the initiatives that India has taken to remove debris, and this is basically the completion of the discussion on the topic of space debris. This completes our discussion on the topic of space debris here, right? I hope all of you guys have been able to understand. So this completes our discussion on space debris. But students, like we have already written here, that India is also working on some future rocket technology like RLV, TD, Pushpak, and the partially reusable NGLV. Let's talk about these rockets as well. Let's quickly talk about these rockets. And this is the second topic of our discussion, which is basically related to the various type of engine propulsion system that India has been developing, right? So students, now we have completed the discussion on debris. Here we have also talked about the various orbits and their applications. Now we'll quickly talk about the rockets and their propulsion systems. Okay, so let's see guys. So when it comes to launch vehicles, of India, when it comes to our launch vehicles, these launch vehicles, India has made, I'll write down the entire list of all the launch vehicles that we have, right? The first launch vehicle that we made, it was SLV, satellite launch vehicle. Then it was ASLV, augmented satellite launch vehicle. Then we have PSLV, polar satellite launch vehicle. Then we have GSLV, geosynchronous satellite launch vehicle, right? GSLV itself has 2 variants. geosynchronous satellite launch vehicle. GSLV itself have got two variants. One is Mark 1, Mark 2, and then we have Mark 3, which is now also known as LVM3, Launch Vehicle Module 3, Launch Vehicle Module 3. And then we have SSLV. SSLV is called Small Satellite Launch Vehicle. SSLV, Small Satellite Launch Vehicle, right? Launch Vehicle. And these are the launch vehicles that are working. These are the launch vehicles that are there and they are working, guys, already. ये already काम कर रहे हैं, right? And then there are three launch vehicles that are proposed, which are already in the pipeline, right? Three launch vehicles are there that are proposed. They are already in the pipeline. Okay. So those three launch vehicles are NGLV, that may be developed by 2032. Then we have RLV Pushpak, right? That may be ready by 2035. And students, there is one more that is called Lunar Module Launch Vehicle. Lunar Module Launch Vehicle. This is specially for the lunar projects of India, and it is expected to be ready again by 2035. Exclusively for lunar projects, right? These are the three launch vehicles that are already there on the ISRO website, and these are proposed launch vehicles. Now students, when you talk about these launch vehicles, let's talk about their payload capacity. So these two launch vehicles have already been retired, so we don't have to talk about them, right? PSLV carries a payload of 1000 kgs to 1800 kgs, right? GSLV Mark 1 and 2 can carry up to 2500 kgs, and GSLV Mark 3 and LVM3 can carry up to 5000 kgs, right? 5000 kgs. Students, this is basically in the geo earth orbit. It can carry up to 5000 kg. If you want to take the satellites to the lower earth orbit, then the payload capacity can be up to 8000 kgs. 8000 kgs in lower earth orbit can carry. This is 5000 kgs in the geo earth orbit. Of course, guys, the longer the distance you travel, less payload you can carry, because the fuel consumption will be much higher. And then SSLV is 500 kgs. 500 kgs. Right, 500 kgs. And this SSLV has been dedicatedly made. This has been dedicatedly made for small satellites. We normally identify small satellites under 4 categories. We call them mini-sats. Mini-sats are satellite from 200 kgs to 500 kgs. We call them mini-sats. Then we have microsats. Microsats are less than 200 kgs. Then we have nanosats. Nanosatellites. Nanosatellites are less than 10 kgs. And then we have CubeSats. And CubeSats are less than 1 kg. Right? Less than 1 kg CubeSats. Mostly 3D printed satellites are nanosats, CubeSats of small, payload capacity only. So these are the various satellites launch vehicles, and these are their payload capacity. Small satellites ke liye we have the SSLV, and then we have these Mark 1 and 2 and such, right? PSLV and such. Now students, when you talk about these launch vehicles, we should also know how are they powered. What is the way of powering them? So we don't have to talk about every launch vehicle here. I'll just talk about the PSLV and GSLV. So when you look at the PSLV here, you can see PSLV is 4 stage. PSLV is a 4-stage launch vehicle. You can see the 4 stages. We use a proper color coding scheme to identify the 4 stages. It is already identified for you here, right? 4 stages. These are the ones that have been already identified, right? Heat shield. All of you guys are aware. So these 4 stages are there. Stage 1 is powered with solid fuel. Stage 1 of PSLV is powered with solid fuel. Stage 2 is powered with liquid fuel. Stage 3 is powered with solid fuel, and stage 4 is again powered with liquid fuel. Liquid, solid, liquid, right? So when you talk about PSLV, it is solid, liquid powered PSLV. When you talk about GSLV Mark 1 and 2, when you talk about GSLV, the stage 1, this is the stage 1, this is stage 2, and this is stage 3. So GSLV is actually a 3-stage rocket. It is a 3-stage launch vehicle. GSLV, it's a 3-stage launch vehicle, guys. Stage 1 is powered. Stage 1 is powered with solid fuel. This is stage 1. This is powered with solid fuel. Stage 2 is powered with liquid fuel. And stage 3 is powered with cryogenic fuel. Cryogenic fuel. Stage 3 is powered with cryogenic fuel, right? Cryogenic. The same applies to GSLV Mark 3 or Mach 3 or LVM 3. This is also 3 stages, guys. Stage 1, stage 2 and stage 3. And these 3 stages are again powered with the same thing. It is stage 1 solid fuel, stage 2 it is liquid fuel, and stage 3 is cryogenic fuel. Okay, so these are the 3 stages and these are the 3 types of fuel. Now students, this is what we have already in our launch vehicles. These are the 3 stages. Even GSLV Mark 3 is also 3-stage rocket. This is also a 3-stage launch vehicle, just like GSLV Mark 1 and 2. This is the distribution of rockets and their payload capacities and also their fuel consumption. Now students, solid liquid fuel were not in the news last year. There were no discussion on solid liquid fuel rockets, right? So I'm going to typically talk about the 3rd stage, because in cryogenic engines, India has made some strong or some big achievements in cryogenic engine technology, right? So there are, if I talk about, see, the future propulsions, if I talk about future of propulsion systems, there is going to be liquid methane, and liquid oxygen, right? We call it methanox. See, in my foundation classes, I have talked about liquid and solid fuel engines also. So in my foundation classes, we have discussed that quite extensively. So if you guys have already, many of you are already my own students, so you can simply go through the lectures, you can simply go through the class notes, you'll be able to understand. Even if you have taken the classes 3-4 years back, that will also not be a problem, because everything has been written in such a way, because it's an old thing. So old things you can easily update from your notebooks itself. But if you talk about the future propulsion system, we have one propulsion system that is liquid based, liquid methane and liquid oxygen. We call it methanox. Then guys, we have liquid kerosene. Of course, kerosene is liquid, and then liquid oxygen. This is called kerolox. Kerosene plus liquid oxygen. And guys, this kerolox is called semi-cryogenic technology. This is also called as semi-cryogenic technology, right? And then comes the 3rd one, that is liquid hydrogen plus liquid oxygen, and this is called cryogenic technology. Right? These are the 3 types of future propulsion systems that we have, right? 3 types of future propulsion system. Let me talk about these propulsion system one more time with a different context. So students, if you look at PSLV, PSLV is a 4-stage launch vehicle, right? Stage 1, I am basically writing it for your benefit. Stage 1 is powered with solid fuel. It is having a solid fuel, guys. Stage 2 is powered with liquid fuel. Stage 3 is powered with solid fuel again. And stage 4 is powered with liquid fuel, right? Liquid fuel. These solid liquid fuels, they are basically used in order to provide the right amount of propulsion to the payload, and the payload should be deployed to the desired orbit. That's basically the objective. In the foundation class, we have discussed these things in a lot of details. I don't see the need of discussing it here. Okay, this is PSLV. Then guys comes GSLV. And in GSLV, these are 3-stage rockets. These are 3-stage launch vehicles. Stage 1 is again powered with solid fuel, right? Stage 2 is powered with liquid fuel in the same way how GSLV is. And then we have stage 3. Stage 3 can be powered with cryogenic fuel. In cryogenic fuel, we use hydrogen. Liquid hydrogen is used as the fuel, and liquid oxygen is used as an oxidizer. I hope all of you would agree to this by now. I hope this is quite commonsensical, that whenever you are carrying any kind of objects to space to burn fuel, to burn any kind of fuel, you need oxygen. You need oxygen to burn fuel. Without oxygen, no fuel can actually burn. You need oxygen to burn fuel. So if you want to burn this fuel also, you need good amount of oxygen, right? So every fuel has to be carried with oxidizer. Oxidizers has to be carried with every fuel. So this would also be oxygen would be carried, liquid fuel with oxidizer. So oxidizer goes without saying. This goes without saying, guys. You don't have to add this oxidizer written everywhere. It goes without saying that every fuel has to be carried with a certain amount of oxidizer, right? Again, in the foundation classes, I discuss the chemical equations. I talk about the ratio of fuel and oxygen. Those are very simple things. Okay. So this is stage 1, 2 and 3, liquid hydrogen, liquid oxygen. Now guys, the problem with this cryogenic engine is, this engine, we have made it indigenously, right? India have made this engine indigenously. We have been just the 4th country in the world to make this engine indigenously, right? Cryogenic engine. But the problem with this liquid hydrogen is that liquid hydrogen is kept at a temperature of minus 256 degrees Celsius, right? And hydrogen otherwise is quite difficult to store, right? Even in my foundation classes, I have already shared, hydrogen is the smallest element in the universe. It is the smallest element in the universe, and that's why it is going to be very difficult to store, because even if I use an iron, steel, cylinders to store hydrogen, hydrogen has to be stored at a very high pressure. You'll have to keep it at a high pressure, guys. Like just to give you a quick comparison, LPG cylinders, the LPG cylinders which are still being used in majority of the country, they have to be pressurized to up to a scale of 120 psi. 120 psi is the pressure gradient for LPG cylinders. You'll be surprised to know hydrogen has to be stored at 3000 psi. 3000 psi. Almost guys, 30 times higher than this LPG. So you can just imagine the pressure gradient has to be very high. To store hydrogen, to store anything at such high pressure is very difficult. So guys, cryogenic engines are good. They provide you a good amount of power, they provide you a good amount of energy. But the problem is, despite of providing good amount of energy, they are difficult to carry, they are expensive, and you can understand hydrogen itself is a very difficult to store fuel. So for third stage, there is a possibility of using another fuel. We call it semi-cryogenic stage. This is another fuel that we have been able to design, and we have successfully tested it now. It's called the semi-cryogenic stage or semi-cryogenic fuel. Here the fuel is liquid kerosene. Liquid kerosene is the fuel. ISRO is calling it as isrosine because they have added some more chemicals in it. They are calling it isrosine. So isrosine is nothing but liquid kerosene plus liquid oxygen. So liquid oxygen is same as oxidizer here, but instead of hydrogen we use liquid kerosene. The advantage of kerosene here is that kerosene is much easy to store. It is much easy to store, guys, and till of course the energy output is less. Energy that kerosene produces is less compared to hydrogen. Hydrogen can carry even heavier payloads, but you can understand we can increase the amount of kerosene and help higher payloads to reach, right? So this is obviously going to be cheaper and better in terms of storage. It is easy to store, less chance of failure is there with isrosine or kerosene, right? So this is what we have under GSLVs and PSLVs. But students, when you talk about NGLV, that is the proposed launch vehicle. This NGLV, this is expected to have one more fuel. It will be most likely cryogenic engine or semi-cryogenic engine, or it may have liquid methane engine. This is also a technology that ISRO is trying to develop, liquid methane. You may be knowing that there is a private company in India called Agni-Cool Cosmos. There is a private company in India called Agni-Cool Cosmos, and this private company, Agni-Cool Cosmos, they have developed world's first. They have made world's first 3D printed liquid methane engine. Methane is CH4, liquid methane engine. Right, liquid methane engine. Agni-Cool Cosmos have made it. World's first 3D printed liquid methane engine. Right, 3D printed liquid methane engine. And NGLV for this, ISRO is also developing a liquid methane engine. We call it Methylox or Methanox because of using liquid methane plus liquid oxygen, right? So this is also called as Methanox. Methanox. So students, sometimes guys, these kind of words can be asked in the UPSC exam. What is Methanox, Kerolox related to? Remember, these are nothing but types of space fuels. I hope all of you guys have been able to understand. Feel free to connect with me, guys. Some of you may not be my own foundation students, so feel free to connect with me, right, if you want to have some background information about these initiatives. Okay, so this is what we have under the various future propulsion systems. So NGLV, our proposed next generation launch vehicle, is going to be having liquid methane or kerosene based engine systems. Okay, now student, let's see some of these details. Let's see some of the things that we have covered here. So CE20, it's called cryogenic engine with 20 kilonewtons or 20 tons of thrust. 20 tons of thrust. So India has made its first fully indigenous cryogenic engine that powers the upper stage of LVM-3, right? LVM-3, all of you know LVM-3 is a GSLV rocket. The propellant operates on liquid oxygen, LOX, and liquid hydrogen. All of you know liquid hydrogen is kept at minus 256 degrees Celsius temperature. Minus 256 is also the freezing point of hydrogen. It is the freezing point of hydrogen, remember this. So we have to keep it at a very low temperature of freezing point of hydrogen. Although students, this particular rocket has been operational since 2014. This rocket has been operational since 2014, guys. It was also used in Chandrayaan 2 mission, Chandrayaan 3 mission, and guys, all LVM-3 commercial deployments. So this particular engine has been there, but now we have made 100% indigenous rocket engine of cryogenic levels. These rocket engines that burn liquid oxygen and liquid hydrogen at extremely low temperature, below minus 250 degrees Celsius, delivering very high power efficiency, thrust to weight ratio than conventional liquid engines, making it ideal for lifting heavy payloads. You guys can understand, GSLV is meant for heavier payloads, so it is easily able to carry heavy payloads into the space. Got it? But you also understand the risk associated with hydrogen. It is difficult to store. Like I said, its difficulty comes from storage, right? And the high amount of pressure that is required to store it, right? It is difficult to store. Got it? So here comes, please wait. So then comes the semi-cryogenic engine. The semi-cryogenic engine is the replacement, the possible replacement of cryogenic engine. And the semi-cryogenic engines are basically, so India has also conducted a successful test. It was basically power head test. Power head test is basically a test which is done before the actual test, right? So before an actual test of the rocket engine, we do a power head test, article. So it is a test that is done before the actual engine development, and this validates the performance of key engine subsystems including gas generators, turbo pumps, pre-burners and all these things, right? So India is working on making a semi-cryogenic engine where the propellant would be liquid oxygen and liquid kerosene, right? More efficient and storable than cryogenic engines. Efficient in the sense of storing more fuel. We can carry more fuel because in liquid hydrogen we have to carry a lot of cooling systems because it has to be kept at minus 250 degrees Celsius, 256 degrees Celsius particularly. But in kerosene we don't have to carry any cooling system. We can carry liquid kerosene, so it can carry more fuel, and in that way it turns out to be more efficient and more cost effective, guys, right? Semi cryogenic engine. We are building a rocket that can produce 2000 kilonewtons of force. The advantages would be that it can provide high density impulse. It is less toxic, more cost effective and easier to handle compared to cryogenic engines using liquid hydrogen, right? And where it is going to be used, it will be likely used in the next generation launch vehicle, NGLV, right? It is going to be helping in the boosters of heavy liftoff and NGLVs, right? Student, this is what we have under NGLV. There is also one more slide under NGLV here. Look at this. So when you look at NGLV, guys, NGLV is considered to be the next generation human rated rocket. Human rated means it will be capable of manned missions. It will be capable to carry humans, right? Human rated. It will be capable to carry humans also in space. It is going to be partially reusable, I have already told you, and it is expected to have a payload capacity of 30,000 kg to the lower Earth orbit, right? 30,000 kgs to the lower Earth orbit. It can carry 30,000 kgs to the lower Earth orbit, right? ISRO have already tested the recovery of the NGLV's first stage. The propulsion system, as you can see, it will be powered with liquid oxygen. Of course, in all cases, liquid oxygen, but the fuel could be cryogenic, semi-cryogenic, and if possible, ISRO I have already told you that is a refined kerosene. If possible, we may also use liquid methane based engines, right? ISRO is working on those liquid methane engines right now. It is going to be useful to carry heavy satellites like communication satellites, heavy deep space missions and human space flights, and also cargo missions to space. Basically, students, what is the main objective behind NGLV is, I'll talk about that NGLV main objective. If you talk about NGLV, its main objective would be, see, just think about it. We already know that India has built satellites which are meant for various applications. And we all know that by 2026-27, by next year, of course, India will also send Gaganyaan, right? By next year, definitely Gaganyaan astronauts will reach space. And when India is able to execute Gaganyaan successfully by 2027, what is the next most natural step? What is the next most natural step once India achieves sending astronauts to space? What is the most natural step to take after this? So students, the most natural step is to have our own space station. I've already told you that USA, Russia and China, these three countries have already built their space stations. Russia does not have any working space station right now, but Russia till 2025, it was a part of International Space Station. USA right now is leading the International Space Station, and China is another country which is having a space station called Tiangong. So these countries have a space station, and there they can send astronauts, they can conduct experiments and come back, right? So when it comes to the future missions from Indian context, after Gaganyaan is built and sent successfully, the most possible future mission is going to be having our own space station. And guys, if you look at ISRO's own website, it is predicted that there is something going to be called Bharatiya Antariksh Station. There is something expected to be called as Bharatiya Antariksh Station, which India is likely to build by 2035. By 2035, India may have its own space station called Bharatiya Antariksh Station, and this Bharatiya Antariksh Station is going to be India's space station, first ever space station. But students, these space stations are likely, this space station is likely to be of 20 tons in weight. It's going to be 20 tons in payload, and it is expected to carry 2 to 3 astronauts. 2 to 3 astronauts in a single mission, and will have a working life of 20 years, right? And a mission life of up to 20 days. It can carry astronauts. So when you are having such expectations to build a space station, it is obvious that PSLV and GSLV would never be able to carry them, right? Because look at the payload capacity of these rockets. Our PSLV and GSLV does not have a payload capacity that goes, look at this, 5000 kgs GSLV. It is not possible to carry them with this. We need much heavier rockets, guys. We need much heavier rockets, and that's where comes NGLV. That's where comes NGLV. NGLVs have the greatest contribution would be that it is going to be carrying 30,000 kgs of payload. That will be the payload capacity of NGLV. And students, they are going to be most likely helping us in carving future missions, especially missions like Bharatiya Antariksh Station, having our own Bharatiya Antariksh Station or space stations. I hope all of you get it. So this particular rocket, guys, this particular rocket is expected to be ready by 2032. It is expected to be ready by 2032, and this is going to be a partially reusable rocket, right? A partially reusable rocket. And so far, whatever information we have gathered, that this NGLV is going to be a 3-stage rocket. NGLV is going to be a 3-stage rocket, right? Where stage 1 is going to be powered with semi-cryogenic engine, right? Stage 2 is also going to be powered with semi-cryogenic engine, and stage 3 is likely to be powered with a cryogenic engine, right? These are the 3, stages, how they are going to be powered right now as per the information available on the ISRO website. But yes, ISRO is also working parallelly on liquid methane engine, so it may use liquid methane also in the place of semi-cryogenic engine somewhere. Okay, but that's just a possibility. UPSC will not ask such a question. Okay, so this is what we have under NGLV. Got it, all of you? I hope all of you guys have been able to understand NGLV. And students, one more thing I would like to tell you here. If you have the Bharatiya Antariksh Station, when you talk about the Bharatiya Antariksh Station here, what is the kind of benefits you can expect from a space station? When you build a space station, what kind of experiments you can do for a space station? So if I talk about space stations, guys, as India is already planning to have Bharatiya Antariksh Station by 2035, a space station is going to be a kind of a laboratory in space. It is a kind of a laboratory in space. What sort of laboratory? It will perform microgravity experiments. Microgravity experiments basically means to study to perform any experiments where the effect of gravity becomes 0, right? Microgravity means where the effect of gravity becomes 0. Effect of gravity is 0. So we can do all experiments that we are doing on Earth. We can do same experiments in space and see how the things are behaving differently when the effect of gravity is 0. So we can take different organisms, study their behavior in space and see how the effect of gravity is affecting them. It is like a laboratory. Then second is we can do astrobiological experiments. Astrobiological experiments means studying the effect of space on living organisms, on humans itself, right? So biology is study of living organism life. Astro means space. So effects of space on living organisms, we call them astrobiological experiments. So how humans are going to be affected in space? When you take humans to space, how are they going to be affected? Astrobiological experiments. Then students, a space station can behave as a shelter. A space station can act as a shelter in space. it can act as a shelter, right? It can also act as a monitoring station. And today, guys, a space station is also acting as a launching station. We have already launched satellites from space. There are a lot of satellites that have been launched from the International Space Station itself. And students, it can be a gateway. It can also behave as a gateway station for future missions, right? Future missions like lunar missions. Suppose if India is sending a probe to moon, we are already sending. Chandrayaan 3 have already been sent. Chandrayaan 4 is planned for 2027. Chandrayaan 5 is planned for the same year 2027, right? By 2040 we are expecting to even send humans to moon. Indians will be roaming on moon by 2040. So future space missions like lunar missions, future space missions like interplanetary missions. Interplanetary means sending to a different planet altogether. So we already have Mangalyaan. India is planning this year or maybe next year we may see Shukrayaan, our first Venus mission. We are also planning to send Mangalyaan 2 interplanetary. So this can be a gateway station for future space missions. All these are the possibilities that open up with a space station. So space station can provide all these services to us. All these services a space station can offer. Got it, all of you? So India is expected to have its own space station by 2035. Bharatiya Antariksh Station. But remember, guys, for this space station, we need a much bigger launch vehicle, and NGLV can provide that particular service. NGLV is being dedicatedly made for such applications, guys. I hope all of you guys have been able to understand. If you talk about the salient features of NGLV, it is partially reusable. It is bigger and more powerful, of course. It carries a higher payload capacity. 30,000 kgs is the payload capacity of NGLV. It is capable of multiple missions. Multiple missions means you can carry missions to the lower Earth orbit and to the geo Earth orbit easily from a single rocket. And guys, it is also going to be launched from the same launching station, Sriharikota, right? The third launch pad is already being constructed, guys. It is already being constructed, which will be compatible with NGLV. Sriharikota is the place where we have our very own Satish Dhawan space station, right? Satish Dhawan space station. I hope you guys know Satish Dhawan was once the head of Dr. APJ Abdul Kalam, and he was the project head for PSLV. And you know that Dr. Satish Dhawan has made the PSLV a reality. Dr. APJ Abdul Kalam served under his command. It was him who was heading the rock, and it was him who set up the launching station also. That's why the launching station is named after him, Satish Dhawan Space Station. I hope all of you guys are able to understand. This is where we have our first launching station, Sriharikota in Andhra Pradesh. Got it? Now, students, there is also another, information about reusable rockets. Acha, there is one more rocket in the discussion here which I missed. That is Lunar Module Launch Vehicle, LMLV, Lunar Module Launch Vehicle. As I told you that this is going to be the heaviest rocket that ISRO will ever build. It is going to be the biggest rocket ever, right? This rocket is going to be replacing NGLV. NGLV itself is going to be our latest rocket, but this rocket is expected to support India's first crewed moon landing by 2040. Guys, let me tell you something here. When you talk about the moon mission, okay, I think I'll be rearranging these slides eventually, students. इनको थोड़ा rearrange कर देंगे. If you talk about the moon or lunar missions of India, just to give you a quick recap, India has launched Chandrayaan 1. It was in the year 2008. Just to give you the quick history. What is their objectives? What is their outcomes? We will talk about them in today's class only. Chandrayaan 1 was launched in the year 2008. Chandrayaan 2 was launched in the year 2019. Chandrayaan 3 launched in the year 2023. right? Chandrayaan 4 is planned for next year 2027. Chandrayaan 5 is also planned for 2027-28, and for Chandrayaan 5 guys, Chandrayaan 4, all of them are going to be indigenous. Till Chandrayaan 4 we'll have all of them indigenous, but Chandrayaan 5 is going to be a joint venture with JAXA. JAXA is Japanese Aerospace Exploration Agency. We are going to joint venture with Japan. There could be other countries also joining us, but Japan ke saath already we have signed a treaty. We are going to have a treaty with Japan on this, right? Joint venture with Japan, JAXA, right? Chandrayaan 5. It's going to be launched by 2027-28 itself. And guys, we are also planning that by 2040, we can't say what is going to be the number of this mission, but we are expecting to have India's first human moon landing. India will be performing its first human moon landing by 2040. This is part of our national space policy of 2023, that by 2040 India will be executing its first human moon landing. You guys probably know already that there are 2 other countries which are having similar missions. You guys may be knowing that USA, under their mission called Artemis, under their Artemis program, by 2028 they'll be sending humans to the moon again, right? By 2028 they'll be sending humans to the moon. Before 2028 they're going to execute it. Actually they will likely to execute it this year only, right? It has got delayed by a long margin because earlier it was planned to be sent by 2024, but now it has been decided that before 2028 they will be doing it, before 2028, right? They are very likely to do it this year or maximum by the early 2027, right? Artemis program. Then guys, China also have a mission that by 2030 they'll be sending humans to moon, right? So humans to moon. So there is a race going on, a new space race is going on to capture moon and moon resources, right? We'll talk further about it when we discuss moon missions. So it is obvious guys, to take humans to the moon, it may not be possible for us to do it with either GSLV or not even possible for NGLV. NGLV and GSLV, they both will struggle to carry astronauts to moon. So India is already working on its biggest rocket ever. We are already working on it, which is expected to have a payload capacity of 27 tons. That means 27,000 kgs to the moon. To the moon it will be able to carry 20,000 kgs, 27,000 kgs, and up to 80,000 kgs it will carry to the lower Earth orbit. So 80,000 kgs to the lower Earth orbit and 27,000 kgs to the moon it will be able to carry. It is going to be a 3-stage rocket, liquid propellant for the first 2 stage and cryogenic in the 3rd stage, right? These liquid propellant, like I said, it could be kerosene, kerolox, or it could be methanox, right? Methane or oxygen. It is expected to be operational by 2035, and like I said, it will be replacing NGLV. It would replace NGLV. Got it, all of you, right? And it's going to be approximately 40 stories tall. That's going to be the height of LMLV, Lunar Module Launch Vehicle. These are the launch vehicles that ISRO is working on. These are the engine technology that we have developed, and this completes our discussion on the topic of rockets. Now students, the space tech startup Agnikul Cosmos, they have announced that its upcoming rocket will be a fully reusable rocket, right? Like SpaceX rockets are fully reusable. Agnikul Cosmos have also announced that they will be fully reusable rocket. Like I said already, that it has already tested a 3D printed suborbital rocket, Agniban sorted. It was the world's first 100% 3D printed rocket, right? The rocket that can be launched, recovered and reused multiple times instead of being discarded after one use. It helps prevent Kessler syndrome, right? Kessler syndrome, by reducing the space debris and enabling controlled re-entry. It will help in preventing Kessler syndrome. I hope all of you understand this is what we have under this reusable rocket. And what are the past efforts of India? The past efforts include RLV TD, RLV Pushpak, right? This is the past effort. And under the global initiative, SpaceX Falcon 9, Falcon Heavy, these are fully reusable rockets. And if you talk about the Long March 8, this rocket is also a fully reusable one. This is also a fully reusable rocket, right? So this is basically what we have under the rocket systems of ISRO and reusable rocket. Student, this is the Pushpak rocket. Like I said, it is a fully reusable rocket. It is based on scramjet engine. Guys, scramjet engine, what is it? We are going to talk about this in defense. It's an important discussion of defense because this was successfully tested last year, right? It's an important current affairs. We'll talk about this in scramjet. It is basically a rocket that can re-enter, RLV, reusable launch vehicle. Then students, after completing the discussion on rockets, let's talk about launch stations or space ports of India. This is an important discussion because it is related to SSLV, small satellite launch vehicles, and we'll talk about SSLV here quickly. Now students, in the previous discussions, we have talked about IADC, Interagency Space Debris Coordination Committee. We have talked about this in the previous discussion. Then students, we've also talked about Outer Space Treaty. We've also talked about United Nations Committee on Peaceful Use of Outer Space and their guidelines that they came up with, right? We have talked about all these initiatives. Now you know what, according to all these initiatives, IADC, Outer Space Treaty, or United Nations Committee on Peaceful Use of Outer Space, out of all these initiatives, there is one common guideline that they all have given, and that guideline is that whenever a country launches a rocket, whenever a country is going to launch any rocket in space, whenever a country launches any rocket in space, that rocket should never fly over a territory. It should never fly over a territorial landmass. Okay, basically what we have here is, we all know that nearly 70% of Earth, is water, right? Nearly 70% of Earth is water, and we all know that if any rocket falls, suppose if the rocket mission fails, it becomes debris, and if that debris falls on water, it is not going to be causing any threat on people, on infrastructure, or public life will not be affected. But if a rocket falls on land, then all of you guys know absolute liability is with the launching station. So all these organizations have suggested that no rocket should fly over land, it should always be flying over water, right? No rocket or no debris should be flying over land or anyone's territory, right? Should not be flying over anyone's territory, right? It should only be flying over the water bodies of Earth, right? Oceans, only above the oceans it should fly. And you know that 70% of the Earth is water only, so it is fairly easy for us to to take them across oceans, water bodies and such. Now if you consider this particular suggestion, let us talk about the spaceport that we have in India. So students, all of you know the spaceport that we have in India right now, it is located at a place called Sriharikota. Sriharikota is at the coast of Andhra Pradesh, all of us know. And if I draw the map, basic map, this is how, right, the map of India appears. This is Sri Lanka, right? And Sriharikota could be located somewhere here. This is Sriharikota, right? It is located somewhere here, right? And then from here, we all know that here we have a landmass, here we have Myanmar, right? So it's quite obvious that whenever satellites are going to be taking off, whenever satellites are going to be launched, the satellites will have to cannot go this path straight away, cannot go in this path. A satellite cannot even go in this path, because in either way you will have to encounter landmass. You cannot fly over Sri Lanka, you cannot fly over Myanmar. So what our launch vehicles are supposed to do, both our PSLV and our GSLV launch vehicles, what these vehicles do, they have to take this curved path. They have to take this curved path in order to maintain their trajectory and follow the international regulations on launching. They have to follow this curved path, right? This curved path needs to be followed. This is what we have under the movement. Now this particular movement of the launch vehicles, we call it dog leg maneuver. This is called as dog leg maneuver. This is called as dog leg maneuver. Okay, this is called dog leg maneuver. Got it? This is dog leg maneuver. So what happens when PSLV and GSLV are launched? They are going to carry this kind of path. Students, this dog leg maneuver is needed whenever you are launching satellites in the lower Earth orbit, right? That is again a part of discussion that we have had in foundation classes, that lower Earth orbit is a polar Earth orbit, right? Whenever you are carrying a satellite in the polar orbit, you will have to perform the dog leg maneuver, right? For polar orbits, right? For polar orbits, you will have to launch satellites. You have to put satellites in the lower Earth orbit like this. Got it? You have to do this dog leg maneuver, right? But now guys, when it comes to SSLV, when it comes to our SSLV, SSLV is a small satellite launch vehicle, and this launch vehicle is having a payload capacity of only 500 kgs, and it is 3-stage. It's a 3-stage launch vehicle and only have a payload capacity of 500 kgs. Now the problem that we have faced is that when we are launching SSLV, SSLV finds it too difficult to do dog leg maneuver. When you want to do dog leg maneuver in SSLV, we found that this dog leg maneuver causes high fuel consumption. High fuel consumption for SSLV. And guys, it increases the cost of launching, increasing the cost of the entire mission, because you end up burning more fuel. And imagine guys, if you're burning more fuel, your payload capacity is already very low to 500 kgs. It will get reduced even further, right? Because you have to burn a lot of fuel, you cannot carry a lot of payload. So then Government of India realized, or we can say Department of Space realized, that we need another launching station. We need another spaceport in India. And guys, in 2023, the union budget approved another spaceport, and that was Kulasekharpattinam. Kulasekharpattinam is going to be our latest or new spaceport that will be set up in Tamil Nadu. It is close to a place called Tuticorin in Tamil Nadu, Tuticorin, and this is going to be our new spaceport, and this spaceport is dedicatedly being built for SSLV. So this SSLV is going to be carrying satellite mostly in the polar orbit only. This carries satellites mostly in the polar orbit, right? Mostly to the polar orbit, and it is being built at the coast of Tamil Nadu, and this will be located close to a place called Tuticorin, right? Close to a place called Tuticorin, right? Tuticorin, and this place Kulasekharpattinam Tuticorin, and this Kulasekharpattinam is going to be our second launching station. But this station is going to be dedicatedly meant for SSLV, guys. It will be dedicatedly meant for SSLV, right? Because SSLV will not have to burn a lot of fuel if we are launching it from Kulasekharpattinam. But students, Kulasekapattinam, once it is expected to be ready by this year end, by 2026, it is expected to be ready. The Union Budget of 2023 announced Kulasekapattinam, but the official budget was released in 2024, right? And it is expected to be ready by this year. This year it will be ready. And students, the benefit of SSLV, the feature of SSLV is, if I talk about the salient features, this SSLV rocket, this is a rocket that is horizontally assembled, right? It is a rocket that is horizontally assembled. That means you do not require large construction of launch pads. You do not require large launch pads to be constructed. You can actually assemble the components horizontally and then erect them so that it can be launched vertically, right? So you do not require large scale launch pads to be built. Of course you need a launch pad, but you do not require a very sophisticated launch pad because it can be horizontally assembled. And guys, another feature is here MSMEs can manufacture components. MSMEs can manufacture components easily and assemble them. It is easy to assemble, right? It is easy to assemble. Like when it comes to PSLV, GSLV, it is difficult to assemble. SSLV is much easier to assemble. So guys, Tamil Nadu, ever since Kulasekapattinam has been identified as the next location, it is having high hopes that once SSLV will be shifted to India, shifted to Kulasekapattinam, it will eventually be supporting the local MSME industry. It can generate a lot of employment, and it can help us in creating high job securities, because you know that the backbone of manufacturing in India is not with large scale industries. It is with MSMEs, micro, small and medium enterprises, and especially small and medium enterprises will be benefited, and it can create an entire ecosystem of space manufacturing. It can create an entire ecosystem of space manufacturers. I hope all of you guys are able to understand. This is the advantage of having the next space station, which is dedicatedly meant for SSLV. Got it? Small satellite launch vehicles. So this is the image, guys. So when you travel from the Sriharikota, you have to do this dogleg maneuver. It burns a lot of fuel, but with Kulasekapattinam, you can see it is close to Tuticorin, right? You can go straight when it comes to putting polar satellites, right? You can go straight into the polar orbit without worrying about violating any international law. Got it? So this is the advantage of having a new spaceport at Kulasekapattinam. I hope all of you guys are able to understand. Let me also tell you one more thing here, because okay, we'll talk about this also, but let me talk about one more feature here. One more important feature I'll talk about here, and that feature is, see, if you talk about space organizations, right? See, if you talk about space, all of you know, guys, the space as a sector is under union list, right? I hope all of you know that in India, all subjects of governance are divided into various lists. So we have union list, we have state list, we have concurrent list, right? All of you know union list is the one where only central government can make laws. State list is the one where state governments can make law, and concurrent list is where both governments can make law, but if the central government has made a law, then it is the central law that prevails, right? All of you are aware. So space sector is a subject of the union list. That means in India we have Department of Space, which is the nodal agency, for all space related initiatives. The nodal agency is Department of Space. Now Department of Space, the chairman of Department of Space is our Prime Minister. Prime Minister is the de facto chairman of Department of Space. Prime Minister is the de facto chairman of Department of Space. He is going to be by default the chairman of Department of Space. He is also, by the way, the chairman of Department of Atomic Energy, right? All of you know. So he is the de facto chairman of Department of Space. Now Department of Space have ISRO. ISRO is the main research and development organization of Department of Space. Remember this. ISRO is not an, it is having autonomy, that's true. It has autonomy of taking its own task, taking its own objectives, plans, everything, but it is accountable to Department of Space, right? Department of Space will appoint the chairman, everything of ISRO, right? Then Department of Space also owns a lot of other institutions and laboratories. You might have heard of the Space Application Center in Ahmedabad. You might have heard of Physical Research Laboratory, Ahmedabad. You might have heard of Indian Institute of Space Technology, which is in Trivandrum, right? You might have heard of Indian Institute of Astrophysics in Bangalore. There are such like lot of other institutions are there, right? Then students, Department of Space also have a marketing organization. It is called Antrix Corporation. It was the main marketing arm of ISRO, marketing arm of Department of Space, because whatever innovations we are doing in India, they should be displayed, they should be showcased to the rest of the world. Every country in the world should know that India is doing these many achievements, India is doing these many innovations. So it is important that all these things should be, showcased to the rest of the world, so that the world knows that yes, there is innovation happening in India. Their rockets are also equally reliable. They are providing it at a cheaper price. So India can generate more and more space revenue, right? We can generate more space revenue, right? So that is the objective of Antrix Corporation. But Antrix Corporation is now dysfunctional. It is now dysfunctional, guys, right? It is there, but it is not doing any major functions, right? It is now dysfunctional here. It is not performing any major functions anymore. Why it is not performing? Because Antrix Corporation was just a marketing organization. But we guys know that today we are facing a lot of challenge from other space startups, especially across the world. There are new space startups, space startups like SpaceX, Blue Origin. These are quite difficult to challenge. They are quite innovative. So what Department of Space has done in March 2019, they established a company called New Space India Limited, NSIL. It's a separate company registered under the Companies Act, New Space India Limited. And this company NSIL, because it's a company, so its objective is very clear. It can imbibe corporate governance. It has board of directors, and those board of directors are going to be accountable towards the shareholders, right? Right now, Department of Space owns the 100% of the company, but it's a company, guys. Remember, company is always going to be having profit motive, right? They will be always having profit motive, right? All of you understand this. So NSIL basically now has 2 rockets under its custody, PSLV and SSLV. These 2 rockets are now under the control of NSIL, and NSIL can find businesses, they are responsible for promoting these 2 rockets and also acquire business opportunities across the world in launching these rockets. So they are also looking for business opportunities across the world, right? These 2 rockets are now with NSIL. So students, being a company, NSIL can go for joint ventures with private sector, right? And we know that private sector could be good in lot of things, especially in better resource allocation. Private sector could be really helpful, right? It can help in sharing budget. It can go for joint ventures, guys, right? Another advantage could be NSIL can also find suppliers, right? And they can also do outsourcing of the things, right? Offsetting, outsourcing, all these things can be done by NSIL because it's a company. I hope all of you get it, right? So this is what we have in terms of profit and how the current space commerce is being seen. Remember students, if I talk about global space commerce, if I talk about global value of space commerce, you'll be surprised to know in the year 2024, 2025 data is not yet been released, but in the year 2024, they were approximately $700 billion worth of industry of space commerce. Global space commerce have been around $700 billion worth. Do you know how much has been India's share? India's share has been approximately $7 billion. That means it is, sorry, US dollars. That means approximately 1%. 1% of the total global space commerce. 1%. Well, it is less than 2% basically. The current space commerce of India is less than 2%. Right? And when I say that it is less than 2%, one thing should be clear in your mind, that when I say it is less than 2%, it means, when I say less than 2%, it means that we need to increase our objective. So guys, in 2023, India released its new space policy. We made our new space policy, and under the new space policy, we have an objective that by 2030, we will have to increase our space commerce share to 8 to 10%. This is the objective. We have to increase our share to 8 to 10%, right? And students, this cannot happen. This cannot happen if only government remains in the business of space. We have to introduce more and more privatization. We have to introduce more and more foreign investment, right? Because we need foreign partners. So here, another objective is to increase private sector participation. Private sector participation has to be also promoted, right? We have to work on increasing private sector participation, and that's why, guys, NSIL has been made as a separate company to work on generating more and more profit with PSLV and SSLV. I hope all of you guys are able to understand. At the same time, Department of Space have also come up with a new regulatory body. It was established in June 2020. It's called InSpace. InSpace stands for Indian National Space Promotion and Authorization Center. Indian National Space Promotion and Authorization Center. Indian National Space Promotion and Authorization Center, called InSpace. And students, this InSpace that we have, this is now, it is headquartered at Ahmedabad in Gujarat. It is headquartered there. And students, this is our main regulatory body now. It is our main regulatory body for non-governmental space activities or entities. It is not going to regulate government space activities. It will be regulating non-governmental space activities. And like I said, guys, Space Promotion and Authorization Center, it will do all kinds of promotion and authorization. It can provide funds, it can provide licensing, all these things, right? For all non-government entities. Non-government also means foreign. So if foreign companies also, right? Foreign, private, everything, non-governmental. You guys know that last year, SpaceX have been allowed to start their services in India. You guys know this, that SpaceX have now been allowed to start, not SpaceX, sorry, Starlink, which is owned by SpaceX, Starlink of SpaceX have now been allowed to start their services in India. They are allowed to begin their services. Starlink of SpaceX. This Starlink initiative of SpaceX was given approval from InSpace only. Only when InSpace gave them approval last year, then only Starlink could start their services. And you guys know that now they have already come up with their services. They have come up with their initial plan, which is too expensive, by the way, right? But they have come up with that. So this is what we have. So when I talk about SSLV, and its importance, you can understand that it can also be an important initiative for generating more and more space commerce revenue for India, right? NSIL is controlling SSLV. So students, with this, I have completed the entire discussions on rockets, right? And also previously we have talked about, this space debris. These were two important topics, and all the current affairs we have discussed here related to these topics. Students, mind my word, there could be other current affairs also that we will face. We will be seeing those other current affairs as well. But don't worry about it, guys. Those current affairs would be there in the PPT and also in the notes, right? But do follow the notes that I'm sharing with you, because notes will have all the content of the PPT as well, right? PPT का content भी होगा उसमें. So I don't see the need of, so you can use the PPT because I have kept the PPT just for my own discussion, so that I can maintain continuity in the class. But when I talk about the handouts that you are going to read, you can, if you want, you can read the PPTs also. There is no harm. But if you can read the ones which are going to be shared in proper A4 sheet, proper organization would be there. I think it would be much more easier for you to understand and follow things in that way. Okay. So students, this is what we have now. Because UPSC surprisingly had never asked this question, but you will always notice that when it comes to setting up space stations, when it comes to setting up spaceports, all spaceports are usually close to the equator. All spaceports are built closer to the equator, right? They all are built closer to the equator. Now, what is the advantage of setting up space stations closer to the equator? What is the advantage that we have? The advantage is simple, because you all know about this concept called Coriolis effect, right? So all of you understand that when the earth is spinning, there is no doubt that the rotational velocity at the pole will be 0, right? Because if I'm standing at the pole, I'm just rotating like this. The speed at which the earth should be spinning is almost 0 at the poles. But the moment when you talk about the equator, the rotational velocity is quite high. It is as high as 1600 kilometers per hour. This is the rotational velocity of or you can say the angular velocity at the equator. And you guys, all of you know the first law of motion, law of inertia, that whenever any body is in motion, it will always prefer to remain in motion. So if you set up a spaceport at the equator where the speed of rotation is already too high, 1400 kilometers per hour, it is obvious, guys, if you launch from here, the satellite will naturally have, or the launch vehicle will naturally use the orbital or the rotational or the spin velocity of Earth and can propel the objects much faster into space by using the natural rotational speed of planet Earth. So this is one advantage of launching it from equator than from the poles. Then second is a satellite launched from a site near the equator in the eastward direction. Eastward, why? Because Earth spins from west to east. The Earth's rotation goes from west to east. So if you are launching it towards the eastern side, first of all, you will receive the initial boost in the form of the surface velocity of rotation, right? And second of all, you can also observe the satellite for a longer period. Just imagine, if you're launching it from the eastern coast, if you suppose this is the western coast, if you launch it from the western coast, the satellite will go like this, right? Because using the orbital velocity, right, using the rotational speed, it will go like this. Naturally, it will tilt. So the satellite will go like this. But you can see that as it is going like this, it is above the landmass, because it is western coast, above the landmass, and it will be violating all these outer space treaty, IADC, everything. But if the satellite is launched from the eastern coast, the satellite will go like this. There is complete water here. There is complete oceans. So the Earth will be spinning, but the satellite will keep moving towards further east side, will always be moving over water bodies, and if any failure happens, the satellite debris will fall only in the water body, right? So why equator is best, and that too from the eastern side? Because the Earth rotates from west to east. The initial boost will help reduce the cost of the rocket launch, and this is the primary reason for launching the satellites in the eastward directions, and that too closer to the equator. I hope students, all of you guys have been able to understand. This is the meaning for, if you do not understand any of these things, because these things I have discussed in a lot of details in the foundation class, because it was not directly related to current affairs, but I have covered it here just for your knowledge here, right? Now students, okay, GSLV, this PSLV C60 I will discuss tomorrow. I will discuss this C60 tomorrow, although there is something called Poem 4. As I said already, Poem was basically the Polar Orbiter Experimental Module. So India launched its space rocket C60, PSLV C60 we launched, and we know PSLV is 4 stage, where the 4th stage becomes space debris, right? 4th stage is the one that can become space debris. 4th stage is the one that becomes space debris. So this rocket was actually launched on 30th of December 2024. It had 2 primary payloads. One is Poem 4. You understand Poem Polar Orbiter Experimental Module, and the other one is SPADEX, Space Docking Experiment. We'll talk about SPADEX. So we'll discuss both of them here itself. Not much to talk about. So POEM 4 is basically, it is the fourth stage. It is not attached in the actual payload. It is attached in the fourth stage of the launch vehicle, right? And SPADEX was basically put in the actual payload, right? So look at this. So this is POEM 4, guys. POEM 4 basically contained a total of smaller modules, and if you remember, a debris capture robotic arm. I have already told you about this in the previous session when we were talking about space debris. India tested a robotic arm that could actually capture the space debris. A debris capture robotic arm. We have tested it. And also, guys, one more interesting thing we did. We were able to successfully germinate cowpea seeds. We are able to successfully germinate cowpea seeds in space. We have become just the fourth country, to perform such an experiment of germinating cowpea seeds, right? Just the fourth country to do this, right? Then, guys, comes SPADEX. What is SPADEX, guys? SPADEX stands for Space Docking Experiment. I'm going a little fast because I'm hoping to finish the discussion on Chandrayaan as well today itself, right? So that tomorrow's class, next class, I can talk about Einstein's work and general science part of space, right? So space docking experiment. What is this space docking experiment? Space docking experiment is basically, like I said already, we have brought two satellites neck to each other and then connected, physically join them. So two different units physically join and become a single unit in space. They become a single unit in space, right? So that's called space docking. These are the two satellites, SGX-1, SGX-2, which were the two satellites that we launched, and eventually these satellites became one single unit, right? SGX-1 and SGX-2. These are the images of the two satellites, and students, we are just the fourth country to perform this. We are the fourth country. It is needless to say which were the first three countries. USA, Russia and China were the three countries, and we basically made these two satellites join into one. Now what is interesting is when you talk about our own docking experiment, we are the fourth country. So we have used two satellites, right? Two microsats were used of 220 kilograms each, and these microsats were first positioned around 5 kilometers away from each other, and then they were brought slowly closer to each other and to 3 meters, and then eventually docking together, completing the successful docking, and then they became a single unit. We also did an undocking experiment as well, and that was also successfully performed. Now this particular docking experiment that we built, it is given a name called BDS, Bharatiya Docking System. The name that we gave to this is Bharatiya Docking System, BDS. It has been indigenously developed by India, right? And this system is called BDS, Bharatiya Docking System. If you compare this Bharatiya Docking System with the International Space Station, then there it is called the International Docking System Standard, IDSS. I have given a brief comparison of the two things here. Like if you look at BDS, it is less complicated than IDSS. IDSS has total 24 motors, whereas BDS have just 2 motors. Just 2 motors are there in the BDS, Bharatiya Docking System. BDS heavily relies on some new sensors that India has developed, that is laser finding, range finding sensors, rendezvous sensors, proximity sensors and docking sensors. The BDS have also been successful with the help of the satellite navigation system that we used. We use our own satellite navigation system to propel these satellites closer to each other and conduct a successful docking. Now, what are the possible missions? What are the future missions? UPSC can ask these kind of questions. The relevance of space docking experiment. So it can help in aiding future space missions. So the first future space mission would be, it can help us in building our own space station, Bharatiya Antariksh Station. This could be a future possibility, right? We can use this for refueling satellites, right? It can help in extending the life of satellites. You can mention that way also. Then space docking will be used in Chandrayaan 4. The Chandrayaan 4 mission that India is going to launch next year, it's going to basically have 2 different parts, and they both are going to be joined together, because right now we do not have a very large rocket. We have to launch it through GSLV only, and GSLV to moon may not be able to carry a lot of payload. So we'll have to do the docking in space, and then we have to carry the entire unit to the moon. So Chandrayaan 4 is also going to be developed with this docking technique. So these are going to be the immediate missions that we can observe, we can imagine with the docking experiment, right? So this is what we have under space docking experiment, guys. And now comes the moon missions. So this would be the last topic for today's class. I'll talk about the moon missions, and then tomorrow when we meet, we'll talk about topics like dark energy, dark matter, because there has been news, Vera Rubin Observatory, there have been different news on dark matter, dark energy. Then I'm going to also talk about Einstein rings. There have been news on Einstein rings, so we'll talk briefly about Einstein's relativity there. And then I'm going to talk about some other news related to space technology, like these NISAR is one project that India and NASA has together built. It was launched last year. Then there are various other observatories. Solar missions we'll talk about. Solar space weather phenomena we'll discuss. These are the topics that I'm going to discuss in the next class. So students, let's now quickly talk about moon missions. So students, when I talk about moon missions, I have already discussed with you that countries like USA have something called Artemis. Countries like China have their mission called Chang'e. They are called Chang'e missions, right? Chang'e, Change, Chang'e missions of China. These are the various missions of USA and China which are there on moon missions, right, for moon. And when you talk about India, India has its own series of missions. We call them Chandrayaan, right? Chandrayaan, it is a series of missions that we have, right? You'll be surprised to know that under Chang'e missions, China have actually already set 6 missions, and all missions have been successful. China have already executed 6 missions. That means Chang'e 6 was the latest of the Chang'e missions, right? Chang'e 6 was the latest one. China, in terms of lunar footprint, if I talk about lunar footprint, China is having the greatest of the footprints, guys. Maximum distribution of lunar footprint is of China with right now. Okay, but like we will mostly concentrate, I have given few information about Artemis and Chang'e both. You can find it in the PPT, also in the notes. But when I talk about Chandrayaan, let us talk about the progress so far. What has been the progress so far, guys? What has been the progress so far for India? Right, we'll talk about India. So if I talk about Chandrayaan 1, Chandrayaan 1 was launched in 2008. It was just an orbiter. It was just an orbiter, guys. It was simply an orbiter. So it simply had to revolve around moon, right? It was just an orbiter which had to revolve around moon. Chandrayaan 1 was simply an orbiter. Okay, just an orbiter, guys. Chandrayaan 1. If I talk about Chandrayaan 2, launched in 2019, this was orbiter plus lander, right? Orbiter plus lander. It also had an orbiter because Chandrayaan 1 stopped working after 9 months, right? It was supposed to work only for 1 year, but it stopped after 9-10 months. It stopped, but it achieved all its objectives. Chandrayaan 1. Chandrayaan 2 had an orbiter plus lander. But guys, all of you probably know that the lander failed. The lander of Chandrayaan 2 failed, right? Then comes Chandrayaan 3, launched in 2023, just within 4 years. And this had a lander primarily. Primarily it had a lander. The lander also had a rover in it, right? You guys know Vikram was the name of the lander and rover was called Pragyan. And along with it, it also had orbiter, but it was a small orbiter, a short mission orbiter, right? Orbiter was there, Chandrayaan 3. And students, if I talk about Chandrayaan 3 and what has been its achievement, Chandrayaan 3 ka achievement kya tha? You'll be surprised to know, students, that Chandrayaan 3 it had made some serious achievements. Number one, it has landed close to the lunar south pole. Close to lunar south pole, and this is called Statio Shiv Shakti. The spot is called Statio Shiv Shakti. Right? This is the location Statio Shiv Shakti, which is the point where it has landed, the landing site of Chandrayaan 3. Second is Chandrayaan 3 not just land, it also performed roving, or it basically, the rover Pragyan, it had moved over the lunar surface. So it has traveled over 200 meters over the lunar surface, right? Then guys, it is needless to say that it did some experiments on surface, mineralogy, all those things it tries to find out. It has tried to find its surface temperature, right? What is the surface temperature of moon? What is the various minerals present on moon, right? Mineral surface temperature, all these things it tried to study. Studied the lunar soil, right? Lunar soil, all these things it studied. This is needless to say. But guys, what else they did? They did a hopping experiment also. Hopping experiment means that on the moon's surface, the lander Vikram, it simply jumped, did a little hopping exercise. By doing the hopping experiment, we could calculate the force required for lifting objects from moon. The force that we need if you want to lift objects from moon. So how much effort would be required if you want to lift the objects away from the moon? Then we did this hopping experiment for that. We did a hopping experiment to lift objects from the moon, right? This is the hopping experiment that we did. And then guys, and then after the hopping experiment, the propulsion module basically means the rocket of Chandrayaan 3, it returned to earth-bound orbit. Basically, once the Vikram lander was successfully dropped towards the moon surface, the propulsion module that was propelling the entire rocket, Vikram lander into the moon gravity, it returned into an orbit that can reach Earth. So it came back to the orbit that can reach Earth, earth-bound orbit. So basically it has designed a trajectory. That can bring objects from moon back to Earth. Guys, I have already told you by 2040 we are planning to send humans to moon. So if humans needs to go to moon, you will have to do an experiment to calculate how much force we require to lift from the moon surface. And then you have to design a trajectory that what path has to be followed by these astronauts or by these rockets to return to Earth. Are you able to understand? That's why it was important to achieve all these objectives. Chandrayaan 3 has done it. Chandrayaan 3 has done all these objectives. I hope all of you get it. So Chandrayaan 3 has been a very phenomenal, very successful mission. But student, now comes Chandrayaan 4. So what is going to be Chandrayaan 4? So this is where comes the discussion on Chandrayaan 4. And students, Chandrayaan 4, which is expected to be launched by 2027, it is going to be India's first sample return mission. It is going to be India's first sample return mission, guys. We are going to bring a sample from the moon back to Earth, right? It is going to be India's first sample return mission. And students, so it is the very obvious thing. In Chandrayaan 1 we simply operated, Chandrayaan 3 we landed, and Chandrayaan 3 we did all the experiments required to return to Earth. And now when we send Chandrayaan 4, we actually want to demonstrate this capability, that whether we can collect a sample from the moon surface and bring that sample back to Earth. That is where comes Chandrayaan 4, a lunar sample return mission. A lunar sample return mission, Chandrayaan 4. I hope all of you guys are able to understand. This is a lunar sample return mission, Chandrayaan 4. I hope all of you understood. Chandrayaan 4, a lunar sample return mission, and this lunar sample return mission is very important, guys. First of all, this should be in your mind, guys. It should be in your mind that why countries are so considerate, why countries are investing so much to have a moon footprint, why the countries are working so much to develop some kind of to have a base on moon, to have missions on moon. What is the importance of moon? So students, remember guys, moon has been found to have helium-3. Helium-3 could be a potential fuel in nuclear fusion. It could be a potential fuel in nuclear fusion. And not just helium-3, guys, it also has tritium, which is also a potential fuel for nuclear fusion. Nuclear fusion is seen as a future of nuclear energy, future of energy security. Helium can be one such fuel, right? So if you want to set up colonies, if you want to set up a launching station, anything you want to set up, you need energy for that. And for that, we may have, nuclear fuel readily available. Then guys, apart from this, there could be other minerals also. There could be other minerals as well, right? Then students, when it comes to moon has less seismicity. Its seismic activities are much weaker seismicity, guys. So if you set up observatories on moon, it will not be affected by the seismic waves or earthquakes on moon. It has much weaker seismicity than Earth, right? I hope you understand. So these are the reasons why all countries are looking forward towards moon, right? It can also be having some rare earth minerals also, right? It has not been clear how many, but rare earth minerals are also expected to be present on moon, right? So that's why a sample return mission becomes even more important, right? Because once we get the samples, we can study them, we can find out what is the mineral composition and everything, right? Now Chandrayaan 4, like I said already under SPADEX, Chandrayaan 4 is going to be launched in 2 different parts, right? Chandrayaan 3, I have already told you, ISRO has demonstrated soft landing on moon, roving on the lunar surface, hopping on the lunar module, and also bringing back the propulsion module from moon to the earthbound orbit. So Chandrayaan 4 is going to be just the next step from Chandrayaan 3. It will demonstrate taking off from the lunar surface and after collecting the samples and bringing back those samples to the Earth, completely protected, completely free from any damage and contamination, right? Completely free from any damage and contamination. That is what Chandrayaan 4 is expected to do, right? It is going to be again the lunar samples returned from southern polar region of the moon. We will collect the samples from there. Much of the science of Chandrayaan 4 is concentrated on analyzing on-ground samples. So mostly Chandrayaan 4 will do on-ground sample studies. It will do most of the studies there itself, but a small part of it is bringing the sample back. Studying the return sample, which is chemically and mineralogically diverse, involves steps ranging from classifying the samples, cataloging the sample preparation, all the way and sample characterization. I hope all of you understood, right? If you look at the information that Chandrayaan 4 has on ISRO website, these are going to be the 5 parts of Chandrayaan 4. This is the ascender module. I don't think this is important. This is not at all important. I've just kept it so that you understand that Chandrayaan 4 will have 2 different parts which are divided into 5 different modules. So there is one module that will be landing. So this ascender module is going to be our lander. Ascender module is going to take off. It will bring the sample back to Earth. So this will be sample return, right? And this is going to be lander, right? This is basically propulsion module. So it will be propelling the entire system, taking it all the way to the moon and then bringing it back to the Earth orbit. All these things are given here, right? I don't think this slide is very important. Just the basic characteristics of Chandrayaan 4 is required, right? I hope all of you get it. Then guys, first let's talk about Chandrayaan 5. Like I said, Chandrayaan 5 is also in the pipeline. This is also expected to be launched by the same year, 2027-28. But in this mission, we are going to be partnering. So this mission is also called LUPEX, Lunar Polar Exploration, and it's going to be a joint project between ISRO and JAXA, Japanese Aerospace Exploration Agency. These two organizations are going to jointly work in Chandrayaan 5, right? The objective is to basically find and study water and water ice on the lunar surface. So this is also a possibility, guys. Moon do have water on its surface. Chandrayaan 1 also in its studies have confirmed that moon does have water, right? So mission would be sending uncrewed lunar lander and a rover to explore the South Pole region of the moon, where no earlier than 2028. ISRO is developing Chandrayaan 5's lander. So lander is being developed by ISRO, whereas JAXA is building the 350 kilogram rover. So JAXA is building the rover and ISRO is building the lander. Got it? It is expected to have a weight of 6.5 tons. It is proposed to lift off from with the Japanese rocket called H3. So H3 of Japan is going to carry it, right? India is not going to carry. H3 of Japan is going to carry Chandrayaan 5. Are you guys able to understand? Chandrayaan 5. The scientific instrument that Chandrayaan 5 would carry, there will be total 7 scientific payloads, right? Which will be contributed by ISRO, JAXA, European Space Agency and also NASA. But it's a joint venture between these two organizations only, right? So students, here I have also covered. So this is everything that India has planned for moon. I have gone a little fast here because most of the things were simple facts. I have given more information than what UPSC is expected to ask. So if you go through these things only that are given in the PPT or in the handout, it should be more than enough, right? If any question is supposed to be asked from moon, it should be more than enough, right? Then guys, some other interesting information on moon that we have. It is, there is a private mission, right? It's called Blue Ghost. It is a second private mission that has been sent to the moon. Of course, the company is not an Indian company; it's an American company, and there they have been able to reach. The private missions have been able to reach to the moon, right? I don't think much is required here. You can just remember that private missions have also been sent, right? Before this, the first mission was Nova Lander. Nova Lander was the first one, right? First private company to reach moon. Both of them are American companies only. Nova Lander was the first one. This is the second one. Got it? Then guys, there was some interesting news that came out last year, is that there are a lot of innovations that have been put into Chandrayaan 3, and ISRO is already working on making new technologies. So there was a news last year that Chandrayaan, ISRO or Department of Space and InSpace, they both have identified some technologies that can have a direct impact in making our current goods much more cheaper, affordable and better. Like for example, we have already used algorithms for Chandrayaan 3. The algorithm that were used for landing of Chandrayaan 3, they can extensively help us in automotive industry. So basically the point is that Chandrayaan's technologies can actually help in various other industries, making these industries more technically advanced, much more sustainable and also much more affordable to an Indian end consumer, right? Otherwise these things would be quite expensive to import from other countries. But ISRO has already made some technologies that can actually help in making our lifestyle better. So Department of Space has identified 150 such technologies. InSpace have identified 166 such technologies which have been developed in various ISRO missions. Like we can use the pressure sensors of ISRO in airbags and safety equipments. We can make daily use equipments like cell phone cameras, air purifiers, memory foam, reflective blankets. They all are developed from space technology. So why can't we use Chandrayaan 3 technologies itself? 3D LiDAR technology for healthcare in predicting lifestyle diseases. We can use it for crowd management. The same 3D LiDAR can be used for crowd management, can be used for better road safety. In Kumbh Mela itself, that was organized last year, we saw the 3D LiDAR technology being used. We can make cost-effective lithium-ion batteries using the ISRO's own patents. We can make noise, shocks and vibration dampening technologies. We can make paints. There is a paint called NRCM 204 which has been made by ISRO, which is highly corrosion resistant. And then there are different types of polymers that they have designed. ISRO has designed a new kind of polymer which is better in protecting electronics, PCBs. So these are some of the applications where space technology can help in other services, goods and services also. So this is a good example here. Then students, like I said, I have covered some basic information about Chang'e mission also. So Chang'e 6 was the latest mission. It was in the news last year. And with Chang'e 6, China has become the first country. To land exactly on the lunar south pole. See, India is said to have landed, closer to the moon south pole. But China has become the first country to exactly land on the lunar south pole. Just wait a minute. Okay. So here I have not given that location, but remember guys, China has become the first country which has exactly landed on the lunar south pole. Okay, maybe alright, so I'll be making a little change on this particular slide because the first slide is not here. There is one slide also. The first slide is not here where I've given that it has become the first country to reach exactly on the lunar south pole, right? So Chang'e 6, it is here guys. And apart from Chang'e 6, I've also covered the Artemis Accord. You will find the Artemis Accord also, right? It is here, Artemis Accord. You can find it. When we discuss in tomorrow's class, we'll talk about this, right? So students, here I've completed the entire discussion up till Chandrayaan 4, Chandrayaan 5. And now tomorrow when we meet, I'm going to talk about the topics that I just now mentioned. This is everything in today's class. In today's class, the first half an hour, I simply talked about this initiative of ours. I want you guys to share this particular video with as many students as possible. It may be helpful, for them to also, to learn something, and if it is needed, they can also join the course for a better reach. It will help us, right? So the YouTube link is already there. You can share this video with others, and this video will also be posted online. All right. So all the best students. I'll be meeting you tomorrow. All the best. Thank you. And one more thing guys, I'll be giving approximately 20 questions to answer in every single class. So 15 to 20 questions. So you can expect there are 15 lectures, and if 20 questions are there in every lecture, you can expect to have at least 300 questions for practice. Okay. So be prepared for that as well. So students, this is everything in today's class. I'll be seeing you guys in the next class. It will be on 12th, right? So today is 10th. So day after tomorrow, I'll be uploading my second video. All the best. Thank you guys.